Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to link the PLC S7-200 Smart CPU SR30 with the TIA Portal V17 by using the simulation for create the project HMI and link to the PLC. So before go to create the project, I would like to explain the concept of this connection. So first we need to have the LAN cable that connect from the LAN port of our computer to the Profinet port of PLC S7-200 Smart by using the LAN cable. And we need to have the software. The first one is Tab 7 Microwin Smart, and the second one we have TIA Portal other software. Other version that we have. Then we can create the project in PLC and create the HMI screen for simulation, and then we can control from the HMI to the PLC. Okay. So let's go to our software to create the project of PLC and HMI screen, and then we can simulation together. So let's go. Okay, so I have installed in my PC as Step 7 Microwin Smart version 2.5 and TIA Portal version 17. So first let's create the new folder for our project. Example test PLC Smart. Then we can open the software schematic Step 7 Microwin Smart to create the example project. So let's go to check the communication. Find the CPUs. Okay, right now it detects one CPU that has IP address 192.168.20.2. Then we can put the manual IP address of our PC. Example, I will put 192.168.20.253 and subnet mask 255.255.255.0. And then click OK. So basically we can create the start stop one more. So I will choose M0.0 for stop from HMI. Yes. And I will choose M0.1 for start from the HMI. And then I will use output Q0.0 of PLC S7-200 Smart. And then we can find the symbol here. Yes. It is the I/O symbol, CPU input 0, I 0.0, and for the output, start from Q 0.0. Then I will hold the signal of output Q 0.0. Okay. And if we would like to start and stop from the I/O, it means that from the push button, we can also insert. I will insert column and then put the I 0.0 and create one more. I will change this one to I 0.1 for start, and then hold the signal by Q 0.0. Yes, and then we can compile the program and save to the folder that we already created here. We can create a new folder, or we can use this folder. PLC S7-200 Smart with TIA Portal version 17. Okay, and then we can download to PLC, stop the CPU and then start the CPU, and we can online. Yes. So right now, if I push the button start from the input of PLC, let's test. Okay, I will push button start. Let's see, the relay is turned on because the output Q 0.0 is turned on. If I push stop, start again, it will start, and PLC is show the signal also. And then we can create the HMI project from TIA Portal for simulation, start and stop from the HMI. Yes. So first, let's open the TIA Portal. So wait a moment for create the project for TIA Portal. So we can go to create the new project and put the project name, example connect PLC S7-200 Smart, and then browse to folder that we already created on desktop. Yes, here, and then choose create one. The project will automatically create the object for us. And then go to project view and create the new device. And we can use HMI and then choose the touch panel that we would like to simulation. Right now I will use TP700 comfort and then choose OK. So wait a moment for create the new HMI. Yes, and then we can choose finish. And we will got the root screen like this. Yes, so this one we can delete. And first we need to create the connection for connect to PLC, right? So double click on connections and put the name of connection, example PLC Smart, and then choose the communication driver that we would like to connect. Right now we connect to PLC S7-200, right? So choose S7-200 and we will use the Ethernet because we use Profinet port, right? So Profinet port of PLC is 192.168.20.2. So we can put here 192.168.20.2. And for the IP address of our computer, we can check IP config. So 192.168.20.253. So we can put .20.253. And then we can go to Hmi Tag. Yes. So we need to create the text. The first one is stop, right? Stop. Let's see, stop from HMI is M0.0, right? M0.0, stop from HMI. So stop PB. The data type is Boolean. And we will use the PLC Smart. It is the connection that we already created. And then put the address, so M0.0. And here we can change 200 millisecond. And then we can create the start button. It is the M0.1. So start PB M0.1, and then cycle time we can use 100 millisecond. And we need to show the status of the relay 1 or motor 1, right? So Q0.0. So we will create motor 1 status. And then it will start from Q0.0. And we will change this one to 100 millisecond also. Then we can compile. So error 0, right? Then we can save, and we can go to our root screen. Basically we can delete and then put the title, example connect PLC S7-200 Smart CPU SR30 with TIA version 17. Then we can go to property to adjust the text size. We can uncheck the fit object, right? We can change the color that we want. I will change the fill to be background. I will change to this color. And for this one, I will increase the size. Okay. And then we can add the push button, right, for control from the HMI. So I will choose button stuff. Increase the font size to be 29. Go to property, general. I will change this one to be solid and change the color to be red. And for the corner, we can adjust to be bigger than this. Yes, like this. And for the text button, I will change to black. Yes. And then we can copy for button start. So start, and then change this one to be blue color. Yes. So it should be like this. And then we can insert the motor. Example, I will use this motor. Okay. And then we need to show the status of the motor. Example, change from color red to white, red to green. So we need to configure the button, right? So right click, go to event, and then freeze. I will use set bit val key freeze, and then we can go to HMI text here. Then we can use like this. We can drag and drop. Example, push button stop. We can drag and drop the push button stop. I will go to root screen again. And then close this one first. Then we can press and choose the function set bit val key press, and then choose the text example stuff PB. And for the start, we can go to event press and then choose set val key press and then choose start. And for the motor stator, we can go to animation, then go to display, add new animation, and choose apparent. And we need to show the motor status, right? Motor 1 status. And change from red to green color when the output is turned on. So we can save the project and then go to simulation. Yes. And then we can test the simulation here. So right now the motor is turned on because we just push the button from the input, right? So example, we would like to stop, we can press stop. Yes. The motor is stopped and relay is turned off. So if we would like to run, we can start from HMI. The motor is start, stop again, start and stop. Yes. So if we would like to start and stop another motor, example, we can go to test another motor. So we can write stop M2 M0.2 stop motor 2 M0.3 start motor 2, and then I will turn on one more output Q0.1 and then hold the signal also by Q0.1, and then we can compile and save the program and then download to the PLC, and we can online, and we will design the screen to start and stop the motor number 2, right? So let's go to our TIA portal, and I will arrange the push button and motor to be like this. Maybe we can adjust. Okay, and here we can copy and then write to be motor 1. And we can copy for motor number 2. Yes. You can select and then right click, copy, right click and paste. And change this one to be motor number 2. And we can copy and paste. For motor number 2. Yes. And then we need to create the text, right? So we need to create M0.3, M0.2 for stop, M0.3 for start, Q0.1 for status of the motor number 2. So let's go to text. So this one should be stop motor 2. The data type is Boolean. We use PLC connection and then start from M0.2 100 millisec and then start motor 2 so M0.3 and cycle time 100 millisec also. And the next we will create the motor 2 status and we will use Q 0.1 and then choose 100 millisec also. And we can compile, save and compile. Okay, compile start with no error. And then we can go to root screen and then go to stop button and then choose the event. And then change this one to stop motor 2. And for this one, event start motor 2. And for this one, we can change to be motor 2 status, right? So that's all. And then we can compile. And then pre-simulation to start simulation with 2 mirrors. Okay, so here we can online and then check for both motor. We have motor 1 and 2, right? And then we have HMI. So we can start motor 1. Yes, motor 1 is running. So motor 2, yes, it's running also. And the PLC is turned on. Okay, I will show the stator on PLC when we push the button from the HMI. Okay, so let's see the PLC is turned on. So if I push stop, example I stop button motor number 2, it stop. Stop motor number 1, it stop. Start again, it turn on again. Okay. So communication between PLC S7-200 Smart and HMI simulation is work perfectly. Yes. So if we would like to count the speed motor, example, we will create one more. I will insert network here. Sorry. Okay. So if output is turned on, I will add and then choose the SM0.4, right? SM0.5 clock 1 second, and then add real. Example, I will add 1.25 to MD 10. Okay, like this. And if the output is turned off, I will move 0. So if Q0.0 is turned off, I will move 0.0 to MD 10. Okay. The same as motor number 2. If motor number 2 is turned on, so Q0.1 is turned on, then I will add real. Example, I will add 1.55 to MD 20. Yes, just example. And here I will insert column. So I will use clock path memory. So MSM 0.5 and then I will use positive edge. And if the motor is turned off, so Q0.1 is turned off, then I will move real 0.0 to MD20. Okay, save the project, compile the project, and then download to the PLC. Okay, so clock PAL memory is working right now. So wait only motor run, and then it will increase the value to MD10, and then we will show on the TIA portal. So we need to create the text. So I will use the motor 1 speed. It is the real, right? MD10. I will use cycle 100 millisecond also, and one more for motor 2 speed. It is the real also, and MD20. Here MD20 for speed motor number 2. Yes, 100 millisecond. Save and compile the project, and then go to root screen, and then we can choose basically we can choose this one. So I will show the motor speed here. Go to property, go to general, and choose the text motor 1 speed, and then we can choose like this, choose this format, go to layout, then go to text format. I will change this text format to be center, this one to middle, and go to apparent, change the color to be black, and then text color to be green, and then change this one to be white, decrease this one, yes, and change the text to be 21, and for the unit is RPM, right? So this one should be RPM. I will change to white color. Okay, and then we can copy for motor number 2. So copy and then paste. Okay, and then change the general to be motor number 2 speed. Okay, good. And we can save and then simulation. Yes. So when the button start was pressed, and then the value will increase, right? So I will start. This one increase, right? So let's check the MD20 again. Why not show? MD20. Oh, this one should be NC, right? I will change to NC because when the motor is not run, the motor 2 is not run, it should be so 0 to MD20, right? So I will download again, and then we can go online. I will zoom in a little bit. Okay, and then we can simulation again. So I will push start, and then the speed the motor will increase. Yes. If I push stop, it will 0. Stop, it will 0. Start again, it will up speed again. Yes. Because we generate with the automatically add, so the speed motor will increase. Yes. So this is just example about how to link the TIA Portal version 17 with PLC S7-200 Smart by using the simulation. Yes. And we can also simulation to be real PLC also. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to connect the PLC S7-200 Smart CPU SR30 to HMI Schneider model GHO certified 02. This is a reply to a comment on my channel about how to connect with the cable RF485 pin that our fan is comment on the previous video. So today I will detail about how to connect the RF485 cable pin assigned that we can connect from COM2 of HMI to PLC S7-200 Smart. For in this pin, we can also use with PLC S7-200 or PLC S7-300 also. Yes. And I will use software Schematic Step 7 Microwin Smart version 2.5 and Schneider software video designer version 6.2 to create the screen, example screen, and then test with the PLC. Okay, so let's go to see the drawing of assigned pin for communication from the HMI to the PLC. So let's go. So here is the drawing that I already summarized with the pin connection of RS485 cable. So for the PLC side here, we use female, and we have 9 pins for this female, right? So we need to use the resistance, 3 resistance. The first one is connect with pin number 6 and pin number 3 with the resistance 390 ohm, and we will parallel with the pin number 8. Yes, with pin number 8, and then connect to pin number 5 that use resistance 110 ohms, and one more for 390 ohm also. Okay, and for the pin number 5, it is the ground, so we can connect with the resistance, and then we use only 3 cables. The first one is ground cable here. Number 5, we connect to number 5 of part of HMI Schneider, and for this pin we use pin number 4 connect with pin number 8. We can welding with the cable, yes, small cable with the resistance. Follow my drawing, yes. So number 5 connect with number 5, number 8 connect with number 2 or number 7, but must parallel with resistance 110 ohms also. And number 3 we connect to number 3 and we can parallel with number 1, yes. Number 2 we can parallel with number 7, and number 6 we can connect directly cable by using the welding to number 9, yes. And we use female for this part or this side. So here we use male and here we use female for connection. So I hope everyone can understand about my drawing. And for the resistance, we not fix only 110 or 390 ohms. So we can use different a little bit. It is no problem. I already test. It work also, yes. So please follow my drawing and then test together, so we can send the data or control the logic from our HMI to the PLC by using this connection. Okay, so we can use the small cable to connect to welding with this connection, and for the length of this cable we can use not over 5 or 6 meters. So for me I use only 2 or 3 meters, so it works perfectly. Okay, so everyone can test with the 7 meter or 8 meter. If it works, it will perfectly, yes. So let's go to our software to create the logic for test with the connection of this drawing. It means that send from the HMI to control the output of PLC. Okay, so let's go. Okay, so first we will create the sample logic and then create the screen for HMI and then download to the HMI. After that we can test together. Okay, so I will create a new folder to keep the project. Example S7-200 Smart with HMI Schneider. Okay, so let's open the schematic. Step 7 microwin smart. Yes. So basically we can insert the hardware configuration. I will insert the CPU SR30. Yes, it is my CPU. And one more thing, have the comment on my video in the previous video also. Yes, our friend comment with the how to set up the setting of the CPU. When turn on and turn off the power, it will run automatically run. Basically, we can go to CPU tab and then go to startup tab and choose the run mode. It is 3 options that we can use. The first one is last, the second one is run, and the third one is stop. If we choose stop like this, it means that when we turn off power and turn on again, the CPU is not run, right? So if we choose run and then download the logic or setting to the PLC, when we power on, it will run. Okay. And for the last, it means that it will remember the last condition of the CPU. Example, the last condition is stop. So when we power on and we choose last, it will stop. When we choose run, it will run. Okay. So it means that the last. So for me, I recommend to use run mode. Yes. And then we can connect the LAN cable. Yes, I will connect the LAN cable from my PLC by using the Profinet port. Yes, to my PC. And then go to communication and choose the correct network card that we already installed. Okay, I will choose gigabit network connection. It is the network card of my PC. So it detect 192.168.20.2. Okay. So if we would like to change the IP, this IP we can use edit, and then we can change it. Yes, change another IP that we want. Yes. But right now I'm not changing the IP. So we need to put the IP address of our PC to be the same rank of PLC. Yes. So I will put 192.168.20 dot something but not dot 2, right? Because the PLC is dot 2. When we put dot 2, it means that it complete the IP. Yes. So I will put 253. Yes. And push tab keyboard, it will give us with the subnet mark 255.255.255.0. Okay. After that, we can click OK, and then we can ping. Yes, ping 192.168.2 .20.2. Yeah, it's so like this. It means that we can connect or we can communication between our PC with the PLC. Okay. So we can create the sample program for test with our HMI. So the first one I will use NC M0.0. Sorry, this one should be M0.1. Sorry, M0.1. And I will turn on the output Q0.0. So this one it is start. So this one I will put start M1. Sorry, stop M1. We can go to the symbol table and then we can change stop M1. And this one start M1. Okay, and we can compile. Yes, error 0. And then I will hold the signal by Q0.0. Okay, and then we can save the project. Okay, this one example PLC project. Okay, and then we can push download to download our logic to the PLC, and we can online. Yes. So we need to create the sample project of the Schneider HMI and then download to the HMI for test, right? So let's go to Open Video Designer version 6.2. Yes, and then we can create a new project. Yes, I will go slowly because easy to everyone can understand. Yes. So push next, I will insert PLC Smart HMI. Yes, can copy and push next. And here it is the target name. I will put PLC Smart HMI connection. Yes, and we must choose the HMI to match with our hardware. So HMI GHO series, and here is the model number, the same as our slide. Yes, here. And then go to next again, and we need to add the driver, right? So I will use Siemens AG, and then we can choose the schematic S7 series. Yes, this one. We can use S7-200 series. Yes. And click OK to confirm. And then choose finish. Yes. It will create the project automatically. Yes. And we need to setting the project, right, to connect with the HMI. So this one should be choose the baud rate. It's very important. If we choose 187500, we can connect with the PLC S7-300. Okay, so right now we will connect with S7-200, right? So we must choose 9600 for transmission speed. Yes, again, if we would like to connect with PLC S7-300, we can use this baud rate. And if we would like to use the PLC S7-200 or 200 Smart, we can use 9600 for transmission speed, and we will connect to COM2 serial interface RF485. Yes, and then this we can use default, so we can click OK. So this setting is very important. If we choose incorrect setting, we cannot communication. Okay, so first we need to know the how to wiring the connection, and the second we need to know about how to use the baud rate. Okay, so right now I will choose 9600 for communication, and then we can go to create the variables. Yes, so go to variable, and then the first one we need to choose the boolean, right, for stop button. So I will choose boolean, and here we can rename. Yes, example stop M1, and this is a scan group. It means that driver that we already choose, and here is the address. So address we can use M0.0, right? Okay, and the next step we can use boolean. Yeah, add one more boolean. Example start M1, and the address is M0.1, right? So M0.1, you can choose this one. Yes, M0 bit 1. Okay, and the next we can use Q0.0 for motor number 1. So we can choose boolean. Example motor 1, and then we can use Q0.0. Okay, and we can back to our screen, and screen here we can change the color, another color that we want. Yes, so we can go to property. Yes, we can go to property, object property, right? Screen 1, and we need to set the download target that we would like to choose. So go to general tab, and then download. Here we choose USB. If we choose file system, it means that we can download to the USB plus or some drive that we want to download to our HMI. Okay, so right now I will use USB type B. Okay, so it have one more option. It is very important here. Include editor. It means that when we already create the project and then we choose like this, we can download to the HMI and then we can upload the project from the HMI back to our PC. Okay, so I recommend to tick this one. Next time we can upload back or back up the project from the HMI. Yes. Okay. And then we can go to push button, right? So let's go to switch. Okay. Label example stop. Stop M1. I will use this font size. Yes. It's very big, right? So we can adjust. Okay, stop M1. Can go to property. And then we can change the platform. Example, we use this color. We can go to change the color, right? Color here. For text color, I will use black. And field color, I will use red because it is stop button. Yes. And we can copy one more for start button. Okay, start M1. We can change the label with the start M1. Yes. And then I will change the color to be blue color. Yes. So we can change to blue. Okay. And for the background, we can change to another color that we want. I will change to this color. Yes. Okay. And then we can use the rectangle to show the status of M1. Example, I will choose like this. Okay. But sometimes we can use the lamp. Yes, like this. We can use the lamp to show the status. Yeah. If we okay like this, it will show like this. Yes. So we can change to color. We can change to when off, it will red, and condition on, it will be green. Yes, like this. Okay. So it is the motor M1. So we need to configure the button start and stop, right? So we can go to property, double click, and then choose the bit and choose momentary on. Yes, because we need to turn on. And go to description, destination, and choose the stop, right? Okay. And for start, the same, we can go to bit, momentary on, start. And for this motor, we can go to variables and choose the motor one. Okay. and then we can compile, right, and simulation before download to the HMI. So I will choose text. Okay, welcome to HMI Schneider with S7-200 Smart. Okay, and then we can change the color or change the font size that we want. The text color I will change to be yellow. Yes. So big, right? So we can adjust. Okay, like this. Then this one should be show the status of motor, right? So I will choose the text. For the label, we can use the text, right? Okay, here we can write the option. When the motor stop, we can show the stop, and when the motor is run, it will show run. Yes. So we can go to enable the value animation. Position, enable the position, the color, enable the color, it is boolean, right? Mode by state, by form, free form. We can use the value animation. Actually, we can use the rectangle. Okay, I will use the rectangle. Have option or not? We have size, we have type, we have visible, fill, right? This one have style also. Actually, we can use the text. Let me find the option. Yes. stop. Normal is stop. And when it turn on, right? When it turn on, it will show running, right? Visible. Okay, so we can translate the text. I will use the label. Yes. And choose the font. It is top, right? I will choose the font size, increase the font size a little bit. So double click on font size and then choose the value. Enable the value animation and choose the boolean. Yes. So here we can choose the motor one. Yes, to translate the text. So when it on, I will show the stator with the motor one running. And when off, I will show motor one stop. Yes, like this. And for color, we can choose boolean also. Color animation. Okay, so when off, I will show the text is red color, and when on, I will show the green color. Yes. And then we can go back to our screen. And then we can save the project and simulation. Yes. Before download to the HMI, we can simulation. Yes. So this one is so big, right? So we can adjust the size like this. And then we can save and then we can simulation again. Okay, it should be like this. So let's go to download to the HMI. So to download the HMI, I will connect the USB Type B from my HMI to my computer. Okay, I will choose Virtual Machine because right now we use Virtual Machine. So I will adjust the position to be center like this. Yes. So we can push download. It means that download the project to the HMI. Yes, to the real HMI. PLC Connect cannot find the detect target machine, right? So let's check again, check the driver again, go to manage to check the driver, go to device manager, and then we can find the HBT. Yes, you can disconnect and connect again. Okay, it shows like this. It means that the driver is working properly. Then we can go to try to save the project and then simulation again before download. Okay, and then we can push download again. It still cannot connect, right? So let me check the HMI again. And then let's try to download. Okay, now we can download to the HMI. So I will change the USB to be 2.0. Yes. And then I will disconnect and then connect the USB again. And then we can try to save and then download the project to the HMI again. Okay. So click yes to confirm download. Yes. We will download the project to the HMI. Yes. So wait a moment for downloading the project. Take time a little bit to download. After that we can test together. So don't touch anything while it downloads. Okay, download finished. So the screen is start up. And then we can go to online with our project. Okay, and then we can test together. Okay, so right now the motor is stopped. So if I push start, okay, the motor is running and the output is turned on. It means that we can connect from this output to the relay or contactor, so we can control the motors. When I push stop, it will stop. Start again, it will start again. Yes. So the condition is stop. This one is running. Yes. So it works perfectly between HMI and PLC. Yes. and then we can continue to write with another motor. Example, we can go to M0.2, M0.3, Q0.1, and then we can hold the signal by Q0.1. Yes, and here we can define the symbol. Example, stop M2, this one start M2. Yes, and then we can save the project and then download to the PLC. And run the PLC again, and we can online, and we need to add more variables to control the motor number 2, right? So I will adjust. Okay, and then we can copy for motor number 2. So right click, copy, right click and paste. We will got like this for motor number 2. And then we can adjust. Okay, like this, and save the project, and we need to create the new variables of this motor, right? So insert the boolean. So example, stop M2. So M2 address is M0.2, right? So M0.2. And one more, start M2. So the address is M0.3. And one more for M2 command, right? So Q0.1. So boolean Q0.1, and this one motor 2. Yes, and we can go back to our screen, and for this one we can go to property or double click, and then change the general, and then go to the stop M1, right? So we can change to stop M2, and this one we can to change to start M2, and for this one we can change M2, and value here we can change M2, and here we can change M2, and here we can change M2, and for the status of M2 here we can change M2, and then we can save and simulation before download to the HMI. Okay, it will like this, show like this on HMI when we download. Yes, so we can save and then download the project to the HMI. Oh, we need to change this one to be M2, right? Okay, go first, and then we can change the button description again. and then download again. Yes, so let's go first. So take time a bit for download the project to the HMI. Okay, finished. So I will rename this one to be stop M2. This one start M2. Yes, save. And then we will try to download again. So wait a moment more for download the project to the HMI again. Yes, to confirm. So wait a moment for download the project to the HMI again. And we can test together after download it. Okay, finish. So we can go to our PLC project and then online and check the status when we push the button motor number 2 and motor number 1. Okay, right now we already downloaded the project from our PC to the PLC, to the HMI. So if I push start 2, Q0.1 is turned on and the stator is green, yes. And for start 1, yes, it worked for Q0.0. And we can stop also, yes. So it worked perfectly, yes. So this is just an example about how to connect the PLC S7-200 Smart with the Schneider HMI. Yes. So before go to the end of this video, I would like to share this one a little bit. Yes. As I show you, if we tick like this, yes, checkbox like this, we can upload from the HMI. Yes. So let me save the project first and then I will close all the projects and we try to upload, right? So we can go to Video Designer and I will upload this project from the HMI. Yes. Okay, I will create the new project or we can cancel the project. So first we need to save and delete the HMI because when we upload it will duplicate the project, right? So I will delete all the project first. Okay, and then we can try to upload editor project. So click here and then choose the USB because right now we use USB, right? And we choose main drive because we upload from the HMI. Yes. So click OK. and wait a moment for upload. Yes, upload complete, right? And then we can open the HMI. We will got the original project. Okay, so that's why I show if we would like to upload the project, we must check box here before we download the design screen to the HMI. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon, and I will drop this project, example project, to the video, and everyone would like to get this project, everyone can download from the link under my video. And the main objective of this project is this connection. If we cannot wiring the connection, we cannot communication, or we cannot control the data from the HMI to the PLC, right? So it is very important for the connection of this pin. That's why I explain this pin assigned with the resistance. Okay, so if everyone have any more question, please kindly drop comment under my video. Yes, and I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to link data from PLC S7-300 to HMI Schneider model GHO3502 by using the RS485 cable for link the data from the PLC to the HMI. And I will use the cable USB Type B to download the project from the PC to the HMI, and use the LAN cable for communication between PLC and PC to create the new project of Schematic Manager, and then test with the HMI. In this section, I will detail about how to connect or how to assign the RF485 pin with the PLC port and with the HMI port. Okay. And in this section also, I will use Schematic Manager for PLC project and Visual Designer version 6.2 to create the project for HMI. Okay, so before go to create the sample project for test, I would like to explain about how to assign the pin for PLC and for the HMI by using the RF485 for communication. Okay, so let's go. So here is the PLC part. So we will use the male of RF485, and we use the resistance connect from pin number 6 to pin number 3, 390 ohm, and series with the pin number 8 with the resistance 110 ohms, and we will connect with the pin number 5 to parallel with the pin number 8 with the resistance 390 ohms also. And for the HMI connection side, we can connect pin number 6 with number 9. We can building, yes. Number 4 with number 8. Number 1 connect with resistance and parallel, or connect with pin number 2 with the resistance 110 ohms. And we will use only 3 cores of cable. The first one is number 5, it is the ground, yes. Number 5 connect to number 5. Number 8 connect to number 7, yes. And number 3 connect to number 3, okay. So for the length of cable, we can use up to 5 meter, yes. And for the transmission rate is very important, yes. For S7-200 we use 9600. For PLC S7-200 and 200 Smart, I already showed in the previous lesson. And for PLC S7-300 we use 187500 for transmission rate. I will show on the configuration with the video designer, okay. And for the HMI side, we use the female for connect with the COM2, yes. So this is the main objective of this video, because we need to know about how to wiring the connection between PLC and HMI, otherwise we cannot test, okay. So everyone can follow this drawing. For the resistance, we not fix 390 ohm or 110 ohm. We can use the similar, yes, resistance, the similar, so we can test also. So now let's go to our software to create the new project for test with the data from the HMI and PLC, okay. So let's go. Okay, so we will use Hmi Tag Manager and Video Designer that I already installed in my PC. So I will create the new project, S7-300 connect with Schneider HMI. Okay, so first we will insert or create the new project on Hmi Tag Manager. So open Hmi Tag Manager. Right now I use version 5.6. Okay, so create the new project. I will put the project Schneider HMI and browse to find the folder that we already created on desktop. So here, and then click OK. And we will insert the hardware configuration for the CPU. In my slide, I will use the CPU 314C 2PN/DP. It has 2 ports of Profinet and 1 port for Profibus. Yes, so we can insert the Hmi Tag 300 station. Okay, Schneider HMI. And then we can insert the rack for schematic S7-300. So I will create the rack. And then we will insert the CPU to match with our hardware. Yes. So 314C2PN/DP version 3.3. Okay. So this is the IP address of the CPU. So click OK. And here we must use MPI because we connect with the HMI. Yes. Property. Yes. Let's see here. 187.5 kilobyte per sec. It is the transmission that I already explained in the slide here. Yes. So we need to choose the transmission rate the same as the PLC port. Yes. So this is the address. It will automatically create it. Yes. Anyway, we can change the address here also. Example, we can change to start from I0. So it will start from I0.0. And for the output, we can also change to 0.0. Yes. So it will start from I0.0 until 2.7 and output Q0.0 until 1.7. And then save and compile the project. And we need download the project to the PLC, right? Download the hardware configuration. So I will connect the LAN cable from my PC to the PLC. And then you can check the IP address here 192.168.0.1. So let's put the IP address of our computer. Maybe I put already, right? Let's check. So I will put 192.168.0.253. And then we can save and then download the hardware configuration to the CPU. So before download, we can go to set PC interface. So make sure we select the connection here and then we can test. Okay, it works. And then let's go to download. So it will find the CPU automatically scan between PC and CPU. So wait a moment for scanning the address of CPU, and it will automatically detect when the PC detects with the PLC. Okay. Okay, so right now it detects one CPU that has IP address 192.168.0.1. So click View. To view the status of the CPU, yes, and then click OK to download. Click OK to confirm, and OK one more time to stop the CPU. And right now the CPU is stopped and complete download, so we click yes to restart the CPU, and the CPU is running right now. And then we can create the sample logic to test with our HMI. So I will go to OB1, I will choose ladder, okay, so we can command send data from HMI to PLC. So we can create the pull button stop, pull button start, and output. Yes, and here I will use M0.0, edit symbol, example stop M1, yes, M0.1, example start M1, and I will turn on the output. So output we already changed from Q0.0, Q0.0, so relay 1, or motor 1, okay, and I will hold signal by Q0.0, so we can save the project and then download to the PLC, and we can online. Okay, so we can go to Video Designer to create the HMI and then download, and we will test with the PLC. So let's go to Video Designer, so double click to open. Okay, so we will create a new project. The project name I will put PLC S7-300 connection. So we can copy from here and paste, and we will choose the correct model of HMI. Yes, there are many models, so I will use HMI GHO series and choose GHO certified 02, the same as our HMI. Yes, so click next again, and add the driver of PLC. So I will choose Siemens AG and choose the schematic S7 MPI/PPI. So in the previous video we learned already about S7-200 series. So right now I will use S7-300 400 series. Okay, and then I will change the background of screen to this color. Yes, and then I will put the text Okay, welcome to PLC S7-300 tutorial. Okay, then I will use the font size to be this size. I will use bold, yes. And we will create the variables for connect with the PLC, right? So M0.0 is stop, M0.1 is start. So we can use variable, create the new variable and boolean. Example, stop relay 1. And this is a driver, yes, so we can choose. And here we can choose M0.0, it is stop, right? And insert one more for start relay 1. M0.1, yes, it is like this, the same as the address of PLC, right? And one more boolean for relay 1 status or motor 1 status, right? So I will put relay 1 status. So Q0.0, yes. And then don't forget check the transmission rate, yes, it's correct. And we'll connect to COM port 2 F485 for serial interface. You can save the project and then go to the screen and configure the screen, right? So I will use switch. Okay, I will put the stop button, stop R1. Okay, stop R1. And I will change the text color to be black and change the color to be red for fill the button. Okay, stop R1. And we have to copy to start R1. Okay, this one should be start R1. And then we will change the color to be blue. Yes. And we need to insert the relay number 1, right? So I will insert the relay number 1. Okay, we can use on off like this. So when the condition off, I will write with relay 1 off, and when it on, I will put relay 1 on. And for the font size, we can use the font size. And then we can use the style like this. Yes. Okay. And we can change the color. Voltage color, I will use black. And for the condition off, I will use the red color. Condition on, I will use the green color. Okay. So if we would like to turn on another relay, we can copy. So right click, copy, right click, paste. And then we can adjust the alignment. So I will change this one to be relay 2. This one should be stop relay 2, stop R2. This one start R2. Okay. So we need to create more for logic, right? So I will outline first and then insert the network. This one for control relay 1. And this one we can paste for control relay 2. I will change description this one to be relay 1. Okay. And then we can insert the push button stop, push button start output, and parallel to hold the signal. Yes. And this one I will use M0.2. It is stop relay 2, right? Stop R2. This one I will change to stop R1. This one I will change to start R1. Okay. And this one should be M0.3, right? So start R2. And this one Q0.1. So relay 2, right? Okay, this one relay 2 also, so Q0.1. Okay. And then we can save the project and download to the PLC, and we can online. And then we can go to create the HMI. Yes, so let's go to variables, insert the boolean. So this one should be stop relay 1, stop relay 2. So m 0.2, yes, this one. One more boolean, start relay 2, m 0.3, and one more for relay 2, right? So relay 2 status q 0.1, yes. And then let's go to screen and then configure the button and relay status one by one, right? Okay, first I will configure the stop button for relay 1. So double click, go to operation, I will use bit and use the momentary on. Destination, I will choose stop for relay 1. This one, double click, go to bit, momentary on, and choose the start relay 1. And this one, go to the variable and choose the relay 1 status. Okay, and for the color, for the label, right, we already put the text for the label. And for button stop relay number 2, can go to bit and choose momentary on also. Stop relay 2, click OK, start R2, go to bit, momentary on, choose the start relay 2, OK, and relay to stator, go to general variable, go to relay to status and click OK. Okay, for this one we already changed, right, for on off. So when off, condition red, when on, condition green. Okay, so we can save the project and simulation a little bit before download to the HMI. Okay, and then we can connect the USB type B from the HMI to our PC. Yes, so I will connect, and then I will choose the visual machine, and we can download. Make sure we check the driver before download. So we can go to manage, device manager, and then see here HBTZ USB. It means that convert from the HMI to USB driver. Okay, so we can download and check delete runtime data and then download the project to the HMI. So take time a bit for download the project to the HMI. After that we can test together. And I will drop the example project under my video so everyone can download and then see the example that I already config or design the screen. Yes. Okay, finish. So we can go to the project of PLC and we can test with the HMI together. Okay, let's see the stator of PLC is turned off. So if I push start button, yes, the PLC is turned on and the stator is show relay on. So if I push stop, yes, stop, start again, and the HMI will show the relay 1 and relay 2 is turned on. Yes. So communication between cable, this cable and HMI is working perfectly. Yes. We can stop, start again. Yes, so it worked perfectly. So this is just example about how to link the data or connect the data from PLC S7-300 to HMI Schneider by using the RS485 cable. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to create the function on TIA Portal version 17 to connect with the PLC S7-300 CPU 314C2PN/DP, and we can create the HMI touch panel screen, and we can start and stop and reset the alarm to the motor that we can create the function. Yes. What is the function? The function is the logic that we can create inside the block, and then we can call the block to use on the main program, and we can download to the PLC. Then we can use for control the electrical devices such as motor, solenoid valve, or something that we want. Okay. In this section, I will use motor 1, 2, 3, yes, by create only one FC, yes, only one function, and we can copy to use with another motors, yes. So basically we should create the input and output that we want. Example, I have start, stop, overload, reset alarm, and for drive is the output that we connect from the digital output to the contactor or relay to control the motors. Okay, and here is the alarm status. When overload, it will trip the output and then show the alarm. Okay, and if we would like to start the motor again, so we can reset the overload and clear the alarm, yeah, or reset the alarm, then we can run continue. Okay, so for this screen we can create only one, and then we can copy to another two pegs, and then we can change the address of the motor 1, motor 2, and motor 3, so we can control. Okay, so let's go to our software to create the new project of the TIA Portal, and then create the screen for test with the PLC S7-300. Okay, so let's go. Okay, so first let's create the new folder. Example S7 PLC S7-300 create function. Yes, and then we can double click on the TIA portal, and then we can create the new project. Yes, so wait a moment for open the software TIA Portal version 17. It take time a little bit. Depend on the computer performance. Yes, so let's go to create the new project. I will put S7-300 create function. Yes, and then we can browse to find the folder that we already created on desktop. So this one, and we can command the project as this project will use TIA Portal version 17 to create both PLC and HMI project. Okay, and then click create. The project will create automatically, follow as our field, the project name, the path, and the comment. Yes, and then we can go to the project view, and then create the new device. Yeah, double click on add new device, and then we can choose the controller. I will use S7-300 station. Yeah, I will use CPU 314C 2PN/DP. Yes, It is version 3.3. Click OK to confirm. Actually, we can both connect to the rack with the PLC hardware, and we can also simulation, right? So right now I will connect directly to PLC. But for the HMI, I have simulation, yes. Because I don't have the hardware of HMI, but we can simulation, yes. So right now we already create the hardware for PLC S7-300 CPU 314C 2PN/DP, yes, here. Yes, CPU 314C 2PN/DP. There are two ports of Profinet and one port for Profibus. Okay. So first let's go to see the hardware. Go to property and then go to input. There are 5 channels of input. Yes. So analog out input has 5 channels, and analog output has 2 channels. Okay. And for the I/O address, analog input, it will start from IW 800 until IW 800H, and for the analog output, it starts from QW 800 also until QW 802. Okay. And for the channel, it is the digital input. It will start from position I 136.0 until 138.7, right? Totally 32 bits. Yes. And there are 16 bits for digital output. So it will start from Q136.0 to Q137.7. Okay, so 16 bits. And then we can go to hardware and then download hardware configuration to the PLC first. Yes. Okay, I will zoom out. Okay. Then we can save the project and we can compile the project before download the hardware to the PLC. Okay, no error occur, and then we can go to download. The CPU and PC will detect automatically. So the PLC is address 192.168.0.1. So I will choose the network card that I already connect the LAN cable from my PC to the Profinet port of PLC. Yes. And then we can start search. It will detect the PLC automatically. with the PC. Yes. So right now it detects one CPU that has address 192.168.0.1. So we can load the hardware configuration first. Okay, we will stop the CPU, stop all. After that, we can finish to start the module. It means start the CPU. Yes. And right now the CPU is running. So we can go to create the function that can control the motor 1, motor 2, and motor 3. Okay. So let's go to program blocks. Yes. And then click add new block. Example block motor. So let's choose FC in mean that function. Yes. And then click OK. We will got one function. Yes, here. Okay, so right now let's see the function is motor FC1. Yes. So here we can create the input output that we want to use, right? So basically we have start, stop, overload, reset, alarm, and dry, right? So there are 4 input and there are 2 outputs. Okay. So first I will create the input for start. It is Boolean, right? So start command. One more for stop command, and one more for overload, right? So input overload. Actually overload we can connect from the digital input, right? From the hardware of overload, so we can connect to the input. Yes. And this one motor overload, and one more for button for reset the alarm, right? So reset alarm. This one for reset alarm, right? Okay, so right now we already create the inputs for start, stop, overload, and reset, right? So next we can go to create the output. We have dry and alarm status. So let's go to output. So dry, Boolean also, and we can command as output to contactor, and one more for alarm stator, right? So alarm motor alarm. Okay. After that we can save the project and compile. Yes, no error occur. And then we can create the logic for control the motor, right? So first I will use NC, NO, coil, parallel with the NO, right? And we need the motor alarm. So I will use NC motor overload, right? So for input we can drag and drop example stuff. This one for push button stuff. Drag and drop the tag. And this one for start. And one more for output, right? Dry. Okay. And one more for overload. And this one should be dry also, right? Okay. And when motor overload, it will show the alarm, right? Because we have alarm status for output. Yes. So I will insert. And this one we can use the command also. Yes. Example command start and stop motor, and this one should be alarm motor overload. So when motor overload, I will use NO contact, and then I will use set, right? So let's go to our bit logic operation, and then I will use set coil. So when motor overload, I will set the motor alarm, right? So choose the alarm here, and then I will use NC one more for cut the interlock when motor alarm. So when motor alarm, we cannot start the motor, right? Okay. And then I will create one more network for reset the motor alarm. So I will use NO. So when we push the button reset, it will reset the alarm, right? So reset alarm. Okay. So that's all for create the logic for this function. Yes. And then we can save. So this is a stop, start, overload, and alarm. When motor overload, it will show the alarm status to digital output. And then we can push reset after we reset the overload hardware, and then we can continue to start the motor. Okay. So we can compile the program. Yes. And we can go to the our main program, double click, and we can drag and drop the motor FC1 to use. Okay, it will show like this. Yes. So here we can command as motor 1 control, and monitoring. So here we can use start address. Example, I will start from M0.0. This one we can rename the text. Example, start M1. Yes. And this one M0.1. stop M1. And this one M1 overload, right? So M0.2. So M1 overload. Actually, this one we can connect from the digital input, but right now we simulation, so I can use the M0.2 first. Yes. And reset alarm, I will use M0.3. So reset alarm for M1. M1 reset. And for the output, I will use the digital output, so we can check the address that I already show in the previous. Yes. So we can check the I/O. So output it will start from Q136.0, right? So Q136.0, this one should be M1 drive. And this one Q136.1. This one should be M1 alarm, right? Okay, so that's all for model number 1 control. Yes, we can save and we can download and then test with the model M1. Yes, and then we can online. Okay, so right now the output is false. So if I force start, the motor will running, right? Because the output is turned on. Okay, I will modify to 0 and force stop. So the output is turned off. The motor is stopped. Yes. And then we can offline. And if we would like to use with the motor number 2, yes, I will rename this one first. So motor 1. So we can copy for motor number 2. So right click, copy, right click, and paste. Yes. And we can change to motor 2. And then we can create the motor 2, drag and drop the motor 2 here. And then this one we can copy. Change this one to 2. Yes. So I will start from M0.4. This one should be start M2, right? Start M2. And then next go to M0.5. Stop M2. And for overload, I will use M0.6. M2 overload, right? And for reset, we can put M2 RST. So M0.7. So M2 or ST. And for the output, I will start from Q136.2, Q136.2 digital output. So M2 dry, right? M2 dry. And for alarm, I will use Q136.3. So M2 alarm. Okay. And we can save, compile. And we can copy for model number 3, right? So right click, copy, right click here, and then paste, and rename this one to be model 3, right? So model number 3. Okay. And this one we can copy. So if we have 4 or 5, we can follow this step. Copy and paste, and then drag and drop to use on the main program. Yes. So drag and drop the model 3 to the network. And here we can use M1.0. So start M3. M1.1. Start stop M3. And for overload, M1.2. M3 overload. Yes. And for reset, M1.3. So M3 or ST. And for the output, I will use Q136.4. M3 dry, right? Okay. Next, the last one, Q136.5. M3 alarm. And then we can save the project and compile the program. There is no error, right? And then we can download the logic to the PLC. Yes. When we tick like this, let's see here, it becomes to FC2 for this one, FC3 for this one. After load, we can check again. This one should be FC1, this one should be FC2, and this one should be FC3, right? So let's start to download. Yes. Let's see here, FC1, FC2, and FC3. And then we can online to see the status of the function. Yes. Okay. So if I would like to start the model number 2, I can push start. Yeah, true. and then we can stop. False, yes. Okay. And if we would like to test for the overload signal, we can test, yes, alarm, right? If we remove the false, it's still alarm, so we need to reset, right? Okay. Reset, and we can remove this one to 0, yes, to be the normal condition, yes. Okay, so we can create the HMI the same as this one, yes, to control the motor one by one. So I will outline first and then save again and add the new device for create the HMI, yes. And then I will use the schematic comfort panel 7-inch. Okay, so wait a moment for create the HMI device and click finish. Okay, then we can delete this one. Okay, delete first, and we need to create the connection, right, to connect with the PLC. So go to connection and then insert the new connection. Example PLC S7-300, and I will connect via Ethernet, and here is the IP address of computer, so we can check with the cmd IP config. Okay, so 192.168.0.253. So I will put this one with 253. And for the PLC is 192.168.0.1, right here. We can check the property, Ethernet address, yes, this one 192.168.0.1, yes, so that's correct. Save, and then go to create the text for HMI, right? So go to the show all text. So the first one, we need to create the M0.0 for start M1, M0.1 for stop M1, sorry, M0.2 for overload, M0.3 for reset the alarm. Yes. So let's go to HMI text. So M1 start or start M1. So the data type is Boolean, so we can choose Boolean, and the connection of the PLC, we can use the PLC S7-300 that we already create here. And then we can use the address M0.0, right, for start. Okay. So stop M1. The address will generate automatically. Yes. Let's see here. M0.1. And the next step, M1 overload, right? M1 reset. Yes. And then M2. Start M2. Stop M2. M2 overload. M2 RST. Yes. Let's see, the address is generated automatically to be the same as the address that we put here. Yes. So it's very easy. After that, we can use start M3, right? Stop M3, M3 overload, and the last one is M3 RST, and we have output also, right? So output, it will start from Q136.0. Yes. So M1 drive, and then we can change the address here. Q136.0. And the next M1 alarm, right? Here, M1 alarm, and then M2 drive, M2 alarm, M3 drive, M3 alarm. Yes. So the address start from Q136.0 until Q136.5. Let's check here. Q136.0 until Q136.5. Okay. And then we can go to the root screen and create the start and stop for motor number 1 to number 3. Yes. I will change or create the title for this animation. Go to apparent and then change the color to be this color, and I will change the background of the screen to this color also. Yes. Okay. And then we can create the label TIA Portal version 17 connect with PLC S7-300 create function. Then I will change the color to be yellow, and this one we can change apparent layout. We can change okay, this color, and then I will select to center, yes, like this. Then we can simulation, yeah, to test the text title. It's very big, right? So we can adjust the size to be 15. Here we can select the layout and uncheck the fit object to contents, yeah, so we can adjust so big, right? Maybe 19 is okay. So big, right? We can adjust to be 17 and test again. Oh, good, right? Yes, okay. So we can create the button for start and stop the motor. Yes. So I will choose the rectangle and then change the color of rectangle. I will use this color, and then we can use the label motor 1, layout, and uncheck the fit object, yes, and this one I will use white color. Yes. Okay. And we can insert the push button, yes. Example, this one for start. So go to property and then go to the general apparent. Then I will use solid and change the color to be blue because it is start button, and we can adjust to be 25 for the size. Yes, and then we can copy for button stuff. Rename this one to stuff and change the color to be red. And both text file I will change to black color. Okay, like this. And let's go to insert the motor. Okay, I will choose this color. Yes, like this. And then I will use the rectangle to show the status of motor. Yes. This one maybe I will use the yellow color. Yes. And this one we can change the color to red. It is the normal or motor is stop status. So it will show the red color. Yes. And then we can configure the button start, stop and status of the motor, right? So let's go to start. Maybe we can increase the size a little bit more. Yes. So right click, go to event. Yes, because we need to press to start the motor, right? And then go to set. We can use set bit Y key press, right? And here we can go to default text table. Single click, yes. And then we need to use the start M1, right? So let's go to M1 start. Yes, start M1. So drag and drop the text to the event here. And for the stop M1, we just click here and then set bit while the key press and stop M1. So drag and drop the text to here. So that's all. And for color animation, we can go to color animation of the motor. Yes, right click, animation, and go to display, add new. So we can choose the apparent. Yes. And then we can drag and drop the M1 drive. So M1 drive, drag and drop here. And here we can change the status. If one, we can change the color to be green. Yes. And we can copy one more for motor alarm, right? Because when the motor is alarm, we should blink the color, right? Another color. So right click, and then we can delete this one and drag and drop the motor 1 alarm to this one, and then change the color to be this one and also blink. Yes. So we need to hidden when the motor alarm, we need to hidden this one, so it will appear this one. Yes. So to do that, let's go to create the new for animation and choose the visibility. So when the motor M1 alarms, drag and drop from 0 to 0, right? And invisible, yes, like this. And basically we can test the function is correct or not. Okay, so right now the motor is not alarmed, so it hidden, right? So if I force the signal for motor number 1, we can online. So let's see here, I will force the signal for motor alarm. Yes, motor overload. Let's see, the screen is pop up with the blink, right? And then we need to hidden this one. So go to root screen, and then this one, right click, animation, and then go to create the new animation, visibility also. And when the motor is alarm, we need to hidden this one, so we can use the alarm here. So we can hidden the status of the motor when the motor is alarm, right? So we can go to 1 and then visible. Yes, and then we can test again. So it doesn't correct, right? So we can change to be invisible. Yes, so this function is okay. So we can go to unforce the alarm, right? And then I will reset the alarm. And let's see, the screen is okay. Yes. So here we can move to be the same position. Yes, like this. So when we start the motor, the status will be green. Yes. Start. Yes, green. Stop. Blue. Sorry, red. And then we need one more button for reset the alarm, right? So we will create one more button. Basically we can copy and paste. This one for clear. Or reset. And then I will change the color of button to be this color. Yes. And we need to change the address, so go to event, freeze, and then go to M1 reset, drag and drop to this one. Yes. And we need to show the status of the motor when the motor is running. Yes. So I will adjust this one to be small a little bit. Yes, like this. And then we can use the text label running. And check the fit object to contents. And then we can change the color to be, I will select solid and then change the color to be green. Center, yes. So when the motor is running, then we can show this one, yes. So go to animation, create the new visibility, and use the M1 drive. M1 drive. And rank from 1 to 1 or from 0 to 0, yes. Okay, let's simulation. So when I start the motor, it will pop up the running, right? This one. So that's correct. So I will adjust this one a little bit, yes. And we can copy for motor number 2 and number 3, right? So select, right click and then copy, right click and then paste. Yes. For motor number 2, and one more for motor number 3, yes. So that's good. And we just change this one to be motor 2, this one to be M2 drive, right? This one to be M2. This one M2 also. this one M2 RST, and for this one is animation, right? So change this one to M2, visibility, change this one to M2, and one more, this one we can change to M1, change to M2, animation also change to M2, and then we can go back to normal. This one we can change to M3 for the status, animation, apparent, change to M2, visibility change to M3, this one also change to M3, this is just basic. When we create the faceplate, we can do faster than this. I will show in the next video. Yes. So M3, this one change the event to be M3, this one M3 RST. Okay, so we can adjust this one to be center, the same position, and we can save the project, and then we can simulation. Yes, I think it worked perfectly. Okay, so we can go to main OB1. Okay, so we can online like this. I will adjust the space for easy to see the status. Yes. So right now the motor 1, 2 and 3 is stop, right? So if I push start M1, yes, let's see the motor number 1 is turned on and output is turned on also. Start this one. Let's see, here is turned on. And for the motor number 3, I will start number 3. Yes. Oh, this one not work, right? Let's check the push button. Let's check the push button start. Go to event. This one should be M3, right? Okay. Sorry. Mistake the address. Yes. So save the project and then go to simulation again. And go to the main OB1 again. And let's test again. So if I push start M3, let's see, M3 is turned on. Yes. If I stop, start again. And example, if the motor M3 is overload, yes, let me force the signal to be overload. Let's see, motor M3 is alarm, yes. And then we can unforce. it's still alarm, right? We need to reset because we use the set function on the output. Yes. So if we start, we cannot start. We try to start, the motor is not run, right? So we need to reset the alarm and then we can start the motor. Okay. So motor number 1 and number 2 is the same. Yes. So it worked perfectly. We can stop, start again. Yes. So this is just example about how to create function to control the motor by using the PLC S7-300 with the TIA Portal version 17. Yes. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And in the next video, I will show and share about how to create the faceplate for this one also. Yes, it's similar to be this one, but we can do faster than this. So I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to wiring PLC Schematic S7-1500 with the push button start and stop and the relay control. So first I would like to introduce the overall of PLC Schematic S7-1500. Here is the CPU 15152PN and here is the part number of this CPU, and I already connected cable power 24 volt DC from this supply, and here is the digital input module and here is the digital output module. For digital input module, there are 16 bits 24 volt DC for input. Example, I connect the push button start and stop from the 24 volt DC to the digital input. Yes. And for terminal 1, it is the digital input number 1. Terminal 2 is digital input number 2. And for terminal 19, it is the supply plus or positive volt from the 24 volt DC, and the 20 terminal 20 is the minus or 0 volt DC. Yes, so we need to supply 24 volt DC to terminal number 19 and 20, and then we can connect from the button to the digital input module. Okay, and here is the digital output module, model DQ16 in min 16 bit 24 volt DC. Yes, and this is a part number of this module, and we need also supply the 24 voltage DC. To terminal number 9, it is the positive. Terminal number 10, it is minus. And terminal 19, it is positive also. And terminal 20, it is the minus. Okay. And I will connect to relay control, for example, this relay. And we will test together with the real PLC. So terminal number 1 connect to the relay, it is the positive, and for minus I will connect to the relay magnetic directly. Okay, so this is just overview of PLC S7-1500 and how to wiring digital input and output with the button and relay control. Okay, and this is the actual PLC. Yes, the real PLC. We can connect to the relay, and this is a push button, start and stop. And I will use TIA Portal V16 to create the new project and then test with the real PLC. Okay, by using the Profinet port connect to my PC. Yes, so let's go to create the new project for test with the basic programming. Yes. Okay, so first let's open TIA Portal version 16 that I already installed in my PC. So we can open, and then we will create the new project. Yes, I will insert the new folder. Okay, I will create the new folder, example project 1. Yes, and let's go to create the new project here. Example test IO project, and then we can browse to find the folder that we already created on desktop here, and then we can click create to create the project and wait a moment for create the project. So take time a little bit for create the project. Okay, and then go to project overview, and first we need to create the hardware configuration. So click add device. Yes, we will create new device. So we have a reference for our slide here. We have CPU 15152PN, and here is the part number, so we can follow this part number. So go to insert the CPU, so go to controllers, go to schematic S7-1500 CPU, and then insert the new CPU, so 15152PN here, and then choose the part number the same as my slide, so 2AM01. Yes, this one, 2AM02. Yes, so 02, this one, and click OK to confirm for create the project. So wait a moment for create the project. Take time a little bit. and then we will test with the real PLC. Yes. Okay, so this is a CPU we already created. So here we can go to property to check the CPU property. Yes, there are two Profinet interface. Yes, so if we click here, we can go to see the property of this part. Yes, so 192.168.0.1. Yes, so this is the IP address of Profinet port 1 and 2, and we need to create the digital input card, right? So DI 1624 DC, and here is the part number. So let's go to add the digital input. Yes, 521 1BH00, right? 1BH00 here. So we can drag and drop. Okay, and next we need to add the digital output 5221 BH01, right? So let's go to DQ and then go to find the 1BH01. So 1BH01, drag and drop to the rack. Yes. So I will zoom a little bit. Okay, so we can zoom like this. So the address will start from, yes, let's check the address. It will start from I0.0, yeah, percent I0.0 until I1.7, totally 16 bits. And for the output, it will start from percent Q 0.0 until percent Q 1.7, okay, totally 16 bits also. So we need to download the hardware configuration to the CPU, right? So I will save the project. So we need to set the temporary IP address of our computer. So CPU is 192.168.0.1. So I will set my computer to be 192.168.0.253. Okay, and then we can download, yes, hardware configuration to the CPU, and then we will create the sample logic to test with the one relay together. Yes, so we need to select the correct network adapter that we already connect the LAN cable from our PC to the Profinet part of PLC. Yes, and then start search. It will automatically detect when the computer scan. Yeah, so right now it detects one CPU 15152PN, and here is the IP address of CPU, and then we can load. Okay, wait a moment for load the project from our software to the PLC. In the load, during load the hardware configuration, we need to stop the CPU. Yes. Okay, I will stop all and then load to the CPU. So PLC will stop when we download the hardware configuration. Okay, and then I will start the PLC up after we download. Yes. So right now the PLC is running, and then we can online. Yes, we can test by online like this. Okay, it's so like this. It means that hardware configuration is download successfully and working properly. Okay, so the stator is run. So we can offline and then create the sample project, sample block for test. Okay, go to the main OB1. Okay, and then we need to create the text, right? Okay, go to PLC text. Okay, so we need to create the text for button stop, button start, and output for relay number 1, right? So for button start, I already connect to I0 dot. Okay, this one button start. Button start this one, I already connect to the I0 dot 1. Yes, and button stop, I already connected to I0 dot 0. So we will create the text. So first we have stop PB. It means that stop push button, and it is the boolean, and start from I0 dot 0. And next we will create the start PB I0 dot 1. Yes, and we have output. Yes, we had output here. Q0 dot 0 connect to the relay control. Yes, so I have relay 1. It will start from Q0 dot 0. Yes, okay, then we can save and compile. Okay, successful. And then we can go to OB1. So we need to create the contact. Yeah, example, I will connect with the NC. Yes, so this one should be stop PB, and for the start PB, sorry, we need to use normal open. So this one should be start, and one coil. This one should be relay 1, and I will hold the signal when push the button start. Okay, and this one should be held by relay 1, right? Okay, and then we can save the project and then compile the program, and then we can download the project to the PLC. Yes, download the logic only, so no need to stop the CPU, and then we can online. Okay, so right now the relay is turned off, then we can test together. Okay, so let's start together. Yes, let's see, the relay is turned off. So if I push start, yes, relay is turned on, and the status of the software TIA Portal is turn on also. So if I push stop, it will stop. If I start again, it will turn on again. Okay, so it works perfectly. So if we would like to link with the HMI, we can also insert. Yes, I will go offline first and then insert the HMI. Yes, so add new device. I will insert the 7-inch for TV 700 comfort. And we also can simulation. Yes. Okay, so create the new. Okay, PLC 1. Finish. So we can test with the real PLC and we can also test with the simulation. Yes. So first let's go to the HMI connection. Yeah, insert the connection. Example, I connect to PLC S7-1500. Okay, and here is the port Ethernet. Okay, and we need to add the text of HMI, right? So in this case, I will create the internal address. Example, stop from the internal. Example, I will use one more NC. Actually, we can create the PLC tag first. Stop HMI. It is the boolean, and I will use the M 0.0 start from HMI. M 0.1, and for the status I will use the relay 1. So we need to create the text. And this one, it is stop, right? So stop from HMI. And I will parallel with start from HMI. Okay. Then we can save the project and then we can go to add the HMI tag. So stop M 0.0, start M 0.1. So stop from HMI. It is the boolean, right? And we will use the connection as PLC 1. Yes. And this one should be like this. So M 0.0, right? Stop. Okay, and for start from HMI, it will start from M0.1. Yes, then we can save, and then we can compile the project. It should be no error, right? So wait for compile. Okay, no error occur, and then we can go to the root screen, and we can configure the button and show the status of the relay one. So I will insert the button stuff. I will change the color to be red color. Okay. And for the text, I will use the black color for text color. Okay, like this. And for the start button, we can copy, press Control, drag and drop the mouse. So this one should be start, and I will change the color to be blue. Yes. And for relay number 1, I will insert the motor. Example, we can insert the motor. Go to the equipment. Can adjust like this. Go to industrial. Automation. It is the pump, yes, automation pump. So we can go to motors. Then we can drag and drop the motors to use. There are many styles that we can use. Yes. Example, I will use these motors. Okay. And I will put like this for status of the motors. Okay. I will use red color. It is the status off. So when the relay is turned on, the motor is turned on also. Okay. Motor is running. So we need to configure the button. Please. I will set bit stuff. Stop from HMI, right? And for the release, I will reset bit stuff from HMI. And for the start, also I go to please set bit start. Yes. Okay, for the stator of motor, I will go to animation and then go to the display and insert the apparent. And then I will choose take relay. We not yet insert, right? So I will insert one more for HMI Tag. So this one should be a relay one or motor one. Q0.0, right? Okay, save the project and then compile. Error, right? Because we not yet set the property of this motor. So go to property and then insert the text. So this text should be motor, right? Okay. And for condition, we can go to add, and when the condition 1, we can change the color to be green. Save the project again, and here we can put the text. Example motor 1. Go to property. We have text color. I will change to yellow. And for the background, we can change to another color that we want. Example, this color. Yes, like this. So I will increase the size to be 27. And for the text size of this color, I will change to 25. Yes. So we can change the status that we want. Save the project, and then we can compile the project again. So the button number 2 is error, right? Let's check the button number 2. Please set bit start, release, reset bit, right? Reset bit start. Okay. And then we can compile again. Yes, save the project and compile the project again. Okay. Function 2, freeze event, right? Start. Okay, so it's still error 1 because this text is incorrect. So we can insert the correct text. Yes. So that's correct, and then we can compile again. So there is no error occur, right? And then we can simulation. Yes. We can simulation. Okay. And then we can go to the OB1 and then online the PLC. Wait for online. Yes. So I will simulation with this one first. Go offline first and then go to simulation. And then we need to simulation from the PLC project first, and then we can simulation with the HMI, right? So start search simulation, and then load the program. And then we can load the project to the simulation. Yes. And then we can start the module. Okay, the simulation was start. Then we can online. Okay, and then we can go to the HMI and start simulation for HMI. So waiting for start and compile the project before simulation. Okay, so right now the HMI was start, and let me adjust the, I will zoom a little bit. Yes, like this, and then we can test. Example, I push start. Yes, let's see, the button is start and motor is running because the output is turned on. When I push stop, it stop. Start again, it start again. Okay, so this is just the basic how to wiring and how to test with the real PLC and simulation with software TIA Portal of PLC S7-1500. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new video that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to hardware configuration of PLC S7-1500 by using the TIA Portal version 17 to make the hardware configuration and then test with the real PLC. So before go to create the new project and do the hardware configuration, I would like to explain about how to wiring a little bit. So here is the PLC S7-1500 CPU 1515 2PN, and this is a serial number or part number of this module, and I already connected the power supply from the 24 volt DC to supply the CPU, and I have three modules. The first one is digital input module 16-bit 24 volt DC. The second one is DQ, it means that digital output 16-bit also, and the third one is digital input 32-bit, it means that 32 point that we can use. And I have push button start and stop. For button start, I already connected to the digital input of module number 3, bit number 1. And for stop button, I already connected the cable to bit number 1 of module number 1. Okay. And I have relay control for test signal the output from the PLC, so we can test, create the sample program for start and stop for control this relay. And I have 24 voltage for supply the PLC and supply the module I/O also. Yes. So here is the real PLC that we can configure and then connect the Profinet port by using the LAN cable to the PC, and then I will use TIA Portal version 17 to be hardware configuration. Okay. So this is a concept how to wiring and how to create the new project that we will do after I explain, and then we can test with the real PLC. Okay, so let's go to our software TIA Portal version 17. Okay, so here is the software TIA Portal version 17. So let's open the software TIA Portal version 17, and then wait a moment for open the software. Take time a little bit. We can create the new folder for hardware configuration folder project. So I will put hardware PLC S7-1500. Okay, and then we can go to create the new project. So click here. I will put hardware config, and then browse to find the folder that we already created. And then we can command the project. And then click create. Take time a little bit for create the project. And then click the project view. Okay, so we can create the new device. So double click the new device. So first we need to add the CPU. Yes. So CPU is 1515 2PN and 2AM02, right? So let's go to Hmi Tag S7-1500, CPU 1515 2PN and 2AM02, right? This one. And then click OK. So wait a moment for create the hardware. And then we can uncheck the protect. Yes. I will choose full access, no protection. Okay, so we can check the CPU. After we insert, we can check the property. Can check the CPU property. So it has two Profinet, right? We can check the Profinet port interface number 1. Here is the IP address of Profinet number 1. And here is the Profinet IP address of port number 2. And here is the startup configuration time, around 60,000 milliseconds. Maximum cycle time around 150 milliseconds. Okay, and we have many functions for this CPU. And then we can go to add the I/O, right? The first one is digital input. So DI 16 24 volt DC, right? 6ES7 521 1B800. Okay, I will insert. So go to DI and then go to the digital input, right? So 1B800 here. Yes, we can check this one, part number, and then drag and drop the module to the rack. We will go like this. So it will start from the I/O tag. Let's check here. It will start from %I0.0 until I0.1.7. And for module number 2, we can go to ES7 522 1B801. So we will go to DQ. And then go to 16, right? This one, 1B801. Yes, this one. So we can check to confirm here. 1B801. Drag and drop the module to the rack again. We will got two modules. Yes, one is input and the two module is output. So we can go to take. It will start from Q0.0 until Q1.7. So totally 16 bits also. And the third one is DI 32 bit. So E6ES7 521 1BL00. So let's go to DI 32 1BL00, and then we can drag and drop, and the address will generate automatically count from this one. This one is earned from I1.7, right? So this one should be start from I0.2 until I7, 5.7. So totally 32 bits for this module, slot number 4. and then we can save the project and compile. Okay, no error occur, and then we can download the hardware configuration, right? So before go to download, we can put the manual IP address of our computer. Yes. So the CPU port number 1, it will start from 192.168.CPU, yes. So 192.168.0.1, and then I will put my computer as 192.168.0. something. So 192.168.0.253, yes. And then we can save, and then we can go to the CPU and then download the hardware. Okay, and then we can choose the correct adapter of network card and choose try all interface to start search, to search the module that we connected the LAN cable to the PLC. Okay, so right now it detects one CPU 192.168.0.1. So we can click load to download the hardware configuration to the PLC. And then click consider to trust and click yes. Okay. Continue without synchronize. And then I will stop all. It means that stop CPU. Yes, we tick like this. It means that stop the CPU for download the hardware configuration. And then we can start the CPU. Okay, so we can create the sample program for test. So right now I already connected the cable from stop button to I0.0 and start button to I2.0, right? So we can go to create the text. So stop VP PB, yes, stop button. So I0.0 and start PB, start from 2.0, right? And for output, I will use Q0.0 to connect to relay control. So relay 1 or motor 1, start from Q0.0, right? and then we can save the project, then compile, and then we can go to program blocks, I will create the NC contact for stop, NO contact for start, and output I will use motor, and then I will hold the signal when we push button start. So I will hold signal by motor 1. Okay, so save the project, and then we can download to the CPU. I will click load, and then we can online to see the status of I/O. And then we can test with the real PLC. Okay, so right now I will push start. Let's see, relay is turned on, and stator on the PLC is turned on also. When I push stop, it will stop, start again, it will start again. So the hardware configuration is working properly. So if we would like to turn on at the output, we can add more. Example, we can turn on the output. We can go to the tag first. Example, motor 2, motor 3, motor 4, motor 5, then we can choose motor 2, motor 3, motor 4, and motor 5, right? Can save the project and compile. Okay, and then we can download. And then we can online and test again. Let's see, the output is turned on 5. Yes, 1 2 3 4 5. If I push stop, it will stop. Start again, it will start. so it works properly with the hardware configuration. So if we would like to start and stop from the HMI, we can also create the simulation. Yes, because right now I not connect to with the HMI, so we can simulation. I will offline first, and then I will create more tag for start and stop from the HMI. Example, stop HMI, stop PB from HMI. I will start from M0.0. Start from HMI. M0.1. Yes. And then here we can push the button stop, right? So I will put here. So stop from HMI. And this one I will parallel with start from HMI. So NO contact. And then start from HMI. Okay, and then we can save the project, compile. Yes, and we need to create the HMI for simulation, right? So we can go to add new device, HMI, and then I will choose the touch panel. I will go to choose the Schematic Comfort and then choose the 7-inch HMI. Yes, because it's just example. So wait a moment for creating the HMI project. Okay, I will choose next. Sorry, back, and then choose the PLC 1. Choose next, and then choose PLC 1, right? Choose finish. Okay, we will got the root screen for HMI TP700 comfort like this, and here we can change the color of the text, sorry, we can change here property, general, so text color I will change to yellow, and change the size to be 2936, right? And then we can change the text. Welcome to TIA Portal version 17 tutorial. Okay, for the screen property, I will change to this color. Okay, it will come like this. And we need to create the HMI tag, right? For connection, we already choose for driver schematic S7-1500. So we need to create the text for HMI. So the first one is start and stop from the HMI, right? So stop from HMI, it is Boolean, and then we use the connection, right? So it will start from M0.0, right? Stop M0.0. So here we can put M0.0, and the second one is start from HMI. So it will start from M0.1, and we need to create the 5 motors status, right? From motor 1 to motor 5. So we will create motor 1 status. It is Boolean also, but start from Q0.0. And for motor 2 status, Q0.1. And we can copy to motor number 5. Motor number 3. Motor number 4. And motor number 5, right? And output should be Q0.1, Q0.2, Q0.3, and Q0.4. Okay, so we can save and then compile. Okay, and then we can go to screen and create the button. Example stop. Okay, and we change the color of button to be red color, and for text I will change to black. Okay, and we can copy for start button. I will change to blue. And then we can go to insert the motor, right? go to WinCC graphic folder, go to equipment, industrial, power mining, automation, okay, motors. So we can drag and drop the motor from this page to use. So I will use this color, or we can use this color. So this one, motor 1, we can add the label. I will change to white color and then increase the size to be 23, and then we can show the status of motor, right? So normally the motor stop is red color, yes, and then we can copy to motor 2, motor 3, motor 4. We can show only motor 4 first. Yes. Because our screen is small, so I will show only 4 motor first. Okay, we will adjust this one a little bit more. Maybe 45 is okay. 43. Then we need to configure the button for start and stop these motors, right? So I will configure for button stop. So go to event, and then freeze. I will set bit stop from HMI, and when I release, we can reset bit from stop from HMI. And for the start button, we can also go to property, then go to freeze, set bit. So set bit start from HMI, and when release, we can reset bit start from HMI. Yes. So that's all for button configuration. Then we can configure the status of the motors, right? So the first one is motor number 1. Go to property, go to animation, go to display, add new animation, apparent, and then choose the tag for motor 1. And for stator 1, I will change to be green color. And for this one, we can copy like this. Yes, copy like this for motor number 2. Go to apparent, and then we can change only this text, and then we can copy for motor number 3. Change this one to motor number 3 status. And for the last one, we can change for motor number 4. Yes, so that's all. And then we can save the project and then compile. Okay, no error occur. And then go to PLC first. Okay, go to block, and then we can simulation for this block. Okay, starting the simulation. Okay, the PCPG interface is simulation, so I will search the CPU. And then load the program. Consider to download. Okay, and then I will start the module. Let's see, here is running simulation, CPU is running, and then we can online. Okay, and we can go to HMI here, and then we can simulation. So starting simulation. Okay, then we can test together. Okay, I will zoom a little bit. Okay, and then I will open the HMI. So we need to change the size of this font a little bit. Yes, so no problem, we can push start. Yes, let's see, all motor is running. Okay, I will change the text to be smaller than this. So maybe 17 is so small, right? 32, and this one maybe 21, and then start simulation again. This one should be motor 1, motor 2 and motor 3, right? So we can go to property, go to the text, go to layout, and then fit object. So we can adjust. And check the fit object to content, then we can adjust. Okay. Then we can save the project and then simulation again. Start simulation again. Okay, good. Go to OB1 and then zoom a little bit. Then go to simulation screen. And then we can push stop, push start. Yes, all motor is running. Push stop and start. Yes. So it's working properly between simulation. So this is just basic how to create the hardware configuration and create the project for HMI for simulation with the TIA Portal version 17. So thank you very much for watching my video. If everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to upload the project from PLC S7-1500 by using the software TIA Portal version 17. So before go to upload the project from the PLC, I would like to explain the concept a little bit. So right now we have CPU of PLC S7-1500, and here is the part number, and I already connected the LAN cable from my PC to the Profinet part of PLC, and here is the I/O module that installed already on the CPU. So if we go to upload, the program will transfer from the PLC to our PC, and we can keep for the document. Okay. Then we can use the project that we already upload or backup from the PLC to download to the PLC back if the hardware of CPU have problem with the accident. Okay, so I will use the LAN cable, yes, to transfer the program from the PLC to keep on the PC. So let's go to upload the project from the PLC by using the TIA Portal version 17. Okay, so let's go. Okay, here is the software TIA Portal version 17 that I already installed in my PC. So first, let's go to create a new project. I will create the new folder. Example, upload PLC1, and then double click on TIA Portal to create the new project. So wait a moment for open the software TIA Portal. Then we can click create the new project and put the project name. Example, upload PLC1, and browse to find the folder that we would like to put or keep our project. Okay, so I will browse to desktop, and here is the folder that we already created on desktop. So double click, and then we can press create to create the project. Take time a little bit for create the project. Okay, then click the project view. And then go to click the accessible devices. And choose the Profinet IE because we already put the LAN cable from our computer to the CPU. And then click Start Search. So wait a moment for scanning the PLC. So right now it detects one PLC by Profinet devices. So 192.168.0.1. So click show, click yes. Okay. And then click add new device, and then go to online, and then upload device as new station, hardware and software. So click here, and then choose the Profinet again, and start search again, and choose the PLC again, and click upload button. Okay, and then click consider as trust the certificate. For version 17, it mostly security, so it will ask the permission when we do something. So right now the program is uploading. So wait a moment for upload. So right now the program or logic, both hardware and software configuration is already uploaded. So let's go to check the hardware. Okay, so right now we have CPU, yeah, the same as my slide that I already show here. We have digital input card and digital output card, and we can go to check the PLC tag or block. Yes, we have 3 PLC tag, and we can go to program blocks and go to main OB1. We will see the example program that we already learned in the previous video, and then we can go online. Here we have only start and stop for relay number 1. Yes, so the CPU still running, yes, because we just upload, and then we can test. Yes, I will test. Okay, right now the relay is turned on. So if I push stop, relay stop, turn on again, relay turn on, and the PLC is show status also. I stop again, start again. Yes. So this is just example, and we can offline and save the project. We will got the project on our folder. Yes, we will got the project here. Yes, around 785 kilobyte. Yes. So this is just example about how to back up or upload the project or program from the PLC S7-1500 by using the TIA Portal version 17. Okay. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new video that I will create step by step. So in this time I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel. Today I would like to create the new project for PC S7 for simulation with the WinCC Explorer. So first let's go to open the schematic manager. In this time I will use PC S7 version 9.0 CV page 1 to create the project for DCS, and then we can simulation with the WinCC Explorer. Okay, so let's go to step by step with me, and then we can simulation with the DCS system. Yes. Okay, I will close all project first. To create a new project, so first let's go to File, and then go to New Project Wizard. And then go to Next. And choose the CPU, yes, that we want to simulation. For example, I will use AF416 1H CPU. Number of communication module, I will choose 0. And then click Next. CFC chart, SFC chart, I don't use. I use PCS OS. And then click Next. And we need to put the project name. Yes, I will create a new folder for the project name. Example PC S7 first project. Okay, example sim project. And then browse to find the folder that we already created on desktop. Yes, and then choose finish to create the project. So wait a moment for create the project. It take time a little bit for create the library and create the project. Yes. Okay, so the project was created, then click OK. We will got the two page of the project. The first one for hardware configuration and the second one for screen, yes, for object. And then we can go to hardware configuration. Okay, so right now we will got the CPU, yeah, for 1658 PN/DP, and we can go to configure the Profinet port. Here is the IP address of the CPU Profinet port, so we can create new example ETM1. We will got like this, yes. And then we can go to simulation, yes. So go to simulation. And make sure we choose the PLC sim TCP/IP and push run P for simulation. and then we can go to hardware configuration, save and compile, and then we can download to the simulation. We will stop the CPU for simulation. And then restart the CPU again. Okay, so we already put the simulation and then download the CPU. Yes. And we need to add the hardware for schematic PC station here. Go to configuration. And then we will go to insert the IE. Yes. So go to schematic PC station. Go to CP, Industrial Ethernet. Go to General and then insert the SW version 8.2. And here we need to put the same as our computer. So I will put the IP address of my computer. Example 192.168.0.12. So I will got and put this one to .12 and tick here and then click OK. Save and then compile and save. And then close. So right now the hardware configuration we already created. So next we can go to insert the library for the object or library, the logic. So go to open and then go to library, go to PCS AP library. Okay, we have a lot of library. Let's see here. We have motor, 2-speed, PID, dry, yes. So we can copy the valve, PID control, motor, yes. Can copy and then close. Sorry, we can go to paste on the project. Okay, we can go to paste on the project. So I will copy, select and copy again. And then paste here. So if we would like to use another library, we can use from here. Yes, we can copy. Okay. And then we can open. Yes, it is the library, so the block is already created. We can download to the CPU. So wait a moment for download to the CPU for simulation. Yes. Okay. Then we can close. I will stop the CPU. Yes. So right now we already download the block to the CPU, and then we can go to schematic PC station, go to OS. Yes. We can go to open, but first we can compile. Yes. So right click on OS1 and then compile the project. So the first time it take time a little bit for compile the project. So we need to choose the network. Yes, let me choose the network here. So before compile, I will go to insert the configuration. For net flow configuration, and here we can see the two devices. The first one is Schematic 400 station. The second one is WinCC Schematic PC station. So we can add the new connection. I will choose S7, and then we can save and compile. Compile and check everything. Yes, finish with no error, and then we can save and then close, and then we can compile again. Click next, next again, and then choose S7 program 1. Yes, next, next again. Connection, we will use this one, 192.168.0.1. Choose next, next again, and compile. It takes time a little bit for compile first time. Yes. So wait for compiling the program. For PC S7 software need the computer with the high performance because it is the big software. Yes, when the compile, it make the CPU and RAM. Yes, let's see, nearly 100%. Yes, for RAM use around 4 GB. My computer is 16 GB and CPU is 2.59 kilohertz. So need the computer with the high performance. It is compiling right now, so take time a little bit for compile the object to the project. So first time it take time, for second time or third time it will faster than this. I will test after we successful build this object. We will test with the second time, so it will faster than this step. Okay, it creating the group display receipt. So it will send from Schematic Manager to WinCC Explorer. Yes. Okay. Compile was complete with warning. No need to show the warning. Yes, it is no error. And then we can go to Schematic Station and then open the object. Sorry, we can go to the OS and then open the object. It will open the WinCC Explorer. And first, let's go to computer property and go to property, go to startup parameter. Okay, no, this one we need to change. Yes, title we tick. Full screen no need to tick. This one no need to check, and then click OK. OK again. And let's go to Tag Management. So open Tag Management. And then go to TCP IP. Yes. System Parameter Unit. And make sure we choose the PLC SIM TCP IP. Yes. Because we use the simulation. And then we can close the WinCC. And then we can open again to refresh the option that we already put, such as WinCC, PLC SIM. Yes. So we need to open the WinCC Explorer again. And we can activate. So it will open the project for us. We will got the faceplate. So wait a moment for open the activation. It take time a little bit more. %. Okay, opening. Open the WinCC runtime. Yes. So not yet complete, right? Okay, complete. So we can click. And then let's see the unit 1. We will got 3 objects. The first one is valve. Yes, we can open the faceplate for valve. The second one, we can open the PID control faceplate. The third one, we can open the valve. The motors. Yes. So here we can simulation. Example, we would like to simulation the motor. So we can go to manual. Example, I go to simulation mode. So we can click simulation and then on the simulation. And then we can go to home. And then we can go to start stop motor. Yes. And then we can pre-start and then click OK. The motor will running. Yes. And for the valve, we can go to simulation mode also. Go to turn on simulation and can go to home and then can we can go to open the valve. Yes, click OK to open the valve. So valve is opening. Yes, and for the PID we can also go to simulation. Yes, we have set point, we had feedback from the PID. Yes, so we can control it for simulation. Yes, so this is just an example about how to create the project of PCS7. This is of PLC S7 that we can simulation for this software. So thank you very much for watching my video. And if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today we will create the new project for PCS7 to simulation with the objects that I will create the hierarchy the same as peg 1, peg 2 and peg 3 and peg 4 by using the PCS7 and WinCC Explorer. Okay, so here is the WinCC Explorer and PCS7 that I already installed in my PC, and here is the engineering or operating system. Yeah, we can call engineering computer, or we can call operating system computer or operator computer. And here is the AS we can call automation system. Yes, and we will connect with the Ethernet cable between central processing unit, yes, and our PC. But in this section I will simulation with the schematic PLC sim, yes, for simulation with the objects. Okay, so let's go to create the new project step by step and we will simulation together. Yes, okay, so first let's open and create the new folder PCS7 create objects. Let's open the schematic manager. Right now I use version 9.1 for PCS7 and WinCC Explorer version 7.5. Yes, so first let's go to file and then new project wizard, and we can preview the project. Yes, and then go next, and here is the CPU. It means that central processing unit that we will use. Example, I use this CPU. Yes, AF410-2H, and this is a number of communication for the module. Yes, I will use 0 and click next, and here is the number of level. It means that number of plant hierarchy In my slide, I will use 4 because we have page 1, page 2, page 3, and page 4. Yes. So I will choose 4. And for the AS object, I will use CFC chart language and PCS7 OS single station system, and then click next. And we need to put the project name, example PCS7 objects, and then browse to find the folder that we already created on desktop, this folder, and then click finish. The project will automatically create. So wait a moment for create the project. It takes time a little bit for this creating. After that, we will do the hardware configuration. Yes. It depends on the computer performance. If the computer is performance good, the speed is so fast. But if the computer is low performance, it will take time. Yes. So wait a moment for creating the program or creating the project. Okay, so we will got like this after created the project by PCS7. Yes. And then we can go to create the hardware configuration. Yes. Before create the objects here. So first we will configure the hardware configuration here. I will rename this one as ES, right? AS1, and rename this one to be OS1. Yes. And here we can go to create the hardware configuration. So double click. And then we will insert the schematic PC station, Ethernet industrial. So drag and drop to the slot. And here is the IP address. So I will put 192.168.0.2. ETM 002. And then save and compile. And here we need to create the hardware configuration also. So go to the Profinet, yes, and then create the new ETM 001. And then we will download the hardware configuration to the PLC sim, right? So we will go to Net Pro. And insert the new connection and choose the S7 connection. And then we can compile and save. Okay, no error occur. And then we will go to create the pegs, right? This one, peg 1, peg 2, and peg 3, and peg 4. So let's go to create the peg here. Yes. I will rename this one to peg 1. Yes. And I will rename this one to screen 1. Yes. And I will insert the new pegs. If we would like to insert the new peg, we can go here, right click, insert the new object, and go to insert the folder, right? RC folder. We will go like this. And then we can rename as peg 2. Yes. And this one, we can create the new. And then we can create the picture. It is the screen 2. Yes. So if we compile like this, okay, let's compile. We will got peg 1 and peg 2. Yes. Okay. Go to OS1 and then go to compile. Next. we will got peg 1 and peg 2, right? So next again, and then don't forget choose the connection here. We might choose the ETM001. Yes. Next again, and compile. So we will got peg 1 and peg 2. Let's see after compile. After we create the peg, so we can create the graphic and create the objects on the page 1 and page 2. So wait a moment for compile the program. So compile first time, it take time a little bit. After second time or third time, we will go fast. Okay, finish without error. And then we can go to simulation. And make sure we select to PLC sim TCP/IP. So I will download the hardware configuration to the simulation. Okay. And then right now the CPU is running, so we can go to open object. And then we can see the page 1 and page 2 on the WinCC Explorer page. So first I will set the property to be this one, title, maximize, minimize, no need full screen, and this one no need. And then click OK. OK again. And for the tag management, we can double click on tag management and then change the connection to be PLC sim. Yes, PLC sim TCP/IP1, and then close. And we can activate the WinCC Explorer to see the page. We will got two pages. Okay, WinCC runtime is opening. So not yet finished. Okay, finish. So right now we will got two pages, right? Page 1 and page 2. So we will insert the page 3, page 4 also. If we click like this, there is no object, right? Because we not yet create the objects. Okay, let's close first and then go to create the page 3 and page 4, right? So to create the page 3 and page 4, let's right click and then go to insert the hierarchy folder and change to be page 3. Yes. And one more. Insert hierarchy folder, change to page 4. We will got 4 pages. And then we can go to compile. Yeah. Yes, change only. And then this one we can compile together. We will got page 4, page 3, page 1 and page 2, right? This one already assigned and this one not assigned, so we will compile this one. Make sure we select the correct connection here. Okay. After that, we can open the WinCC to check again. I will deactivate first. And then activate again. So WinCC runtime is opening again. And let's check together after open. We will got 4 pages. Finish, right? Okay, so let me close and then we need to download, right? I will compile and download again. So I will close the WinCC first. Okay, I will close the WinCC first. And then I will compile again. we need to create the peg first, right? Picture. So insert picture, screen 3, and this one insert picture also, screen 4, and then let compile again. This one also. And then we will download to the CPU also. Yes. Before activate the WinCC Explorer. Okay, compile was complete without error and warning. And then we can download to the CPU again. Yes. All. And run the CPU back. So the CPU is running, so we can go to open the objects. Actually, this one is the CPU redundant, so I will explain in the next video. Go to Take Management to check the TCP IP again. Yes. So we use the PLC SIM. That's correct. So we can activate. So wait a moment for activate the WinCC Explorer, and then the screen will open automatically after activated. Okay, finish. So we will got 4 pages, page 1, page 2, page 3, and page 4, right? So right now the page is empty, so because we not yet create any object, right? So we need to create the objects. So I will close first, deactivate first, and then we will go to create the object. For example, yes, on the page 1 we have unit 1, right? Here. So I will create the objects CFC. Yes, this one example motor 1, and then open the objects. We will use the library for example in this section. Yes, So let's go to library tab here. We have blocks, we have chart, and we have library. So let's go to library tab and then go to PCS7 AP library 91, and then I will go to drive because right now we use the motor. And here is the example library of the motor. So we can use another motor that we want. I will use motor latch. So drag and drop the CFC block to the project. And we will go like this. So here we can go to right click and then object property. And here is the name of the take example motor 1, page 1 motor 1. Yes, this one is the command, so I will use page 1 motor 1 control, and we need to insert the block icon, right? So to see the block icon, we have, this is the class or it is the library name, MOTL. Yeah, so we can go to WinCC Explorer and then we can go to graphic design, double click on graphic design. We will go to check the graphic library on this section. So wait a moment for open the graphic library. Because we need to put the block icon here, right? So let's go to see the library. Okay, PCS7 typical library. Yes, here. So double click. We will see the many library inside these pages. Yes. Okay, so here is the library that we will got after open here. Yes, so the class of motor is MOTL, right? So we will find the class MOTL. Yeah, this one MOTL. So there are 1, 2, 3, 4, 5, 6 style, right? So if we would like to use another style, we just put and check here. It is a style 1, it is a style 2, this is a style 3, this is a style 4, this is a style 5, and this is a style number 6. So the first one I will use type 1. Yes. So we can go to fill this one VR1 and then click OK. And we need to compile the program. Yes. We need to compile. Yes, error 0. And then close. And then we can go to our program and then compile. Let's test one by one to see the result. Yes. And then I will compile this one also. Yes. Make sure the correction is like this. Next, and compile. Okay. And then we will got the one first page on page number 1, yes, faceplate 1. The name is motor 1, yes. And then we can open the screen to see the motor, yes. I will show step by step for easy to understand. So wait a moment for compile the new program. Yes, there is no error occur, right? And then we can download. All. Yes, run the CPU. Check here, make sure the CPU is running like this. And then we can go to open the objects. We already opened, right? Here. And then we can activate. We will got one object. The name is motor 1. And then we can simulation, yes, with the faceplate. So waiting for activate the WinCC Explorer. Okay, opening. And we will got one object name motor 1. Okay. Okay, let's go to page 1 and then open the unit 1. Yes, we will got one motor here. Yes, the name is motor 1. Page 1 motor 1 is the command that we already put on the command. So here we can push start, but it may trip because there is no I/O connect to the block, right? So we can start and it will trip because there is no run return. Yes. So in this page we can go to check here. Yes, I will go to check here. We can open. And here we can increase the size, yes. And then save. So we just refresh the screen. We will got the bigger than before, right? So it's very easy to increase the size or put something. Example, the page 1, I would like to put some library. Example, I will put this one. We just save. And then we can go to refresh the page here. We will got like this. Okay. So for the graphic, we will learn later. Yes. So right now we can go to create the some objects on page 1. Yes. So I will insert one more motor. So CFC. This one should be motor 2. And then open. Go to library. Go to library 91. Go to block. Go to drive. And then I will use this style of motor. Yes. And then we can go to object property. This one is the tag name. Example motor 2. And description, we can motor 2 control reversible. Yes, reversible. and we need to put the block icon, right? So we can go to check on the page also, this page. So remember this one, MOT REVL, right? So MOT REVL, MOT REVL. Yes, this one, MOT REVL. So we have 1 style, 2 style, 3 style, 4 style, 5 style, and 6 style. Okay. So if we would like to use the style 3, example this style, we can use. So here is a style 3. So I will put this one 3 and then compile the program. Okay. And then close it. And then we can go to compile, right? So we will test step by step for easy to understand. Yes. Compile again. So next. It will update, automatically update, right? And then we will download to the CPU also. And then page 2, page 3, and page 4, we will insert some motor, yes, for easy to see the result. Okay, so we can download to the CPU again, all, run the CPU, and then we can go to see the objects, right? Open the objects. Deactivate, and then we will activate again. So page 2 we can go to, sorry, screen 1 we can go to edit the screen. Yes, we will got 2 objects, right? Okay, and then we will activate again to see the result. After that we can insert the more objects on page 2, page 3, and page 4. So page 1 we can put the motors, page 2 we can put the valve, page 3 we can put the some electrical devices. Yeah, example signal of temperature or pressure or something. So we can put on separate the page. Okay. So we will go to page 1, right? Okay. Right now we got 2 motor. The first one is motor, this one. Yes. So we will got 2. Motor 1 and motor 2 here. Yes. and then we can go to the deactivate and insert more objects, right, to page 2. Example, this one we can right click and then insert the new object CFC. Example valve 1, open, go to library, go to library 91, go to drive, and this is the valve. Example, we use the valve motor. We can drag and drop, and then we can go to object property. Example valve 1, valve 1 control, open and close, and we need to put here. So we can go to see the library the same as I show, or we can put number 1 first, compile, and then we can insert more for valve 2. Yes, we can use another class, another library. Example, I will use VLVL. Example valve 2, valve 2 control. I put 1 first, compile the program. Okay. So page 2 we already insert 2 valve. So let's go to page 3. Page 3 I will insert the large motor. Yes. So example motor 3. Go to library, go to drive, and go to the large motor, right? Speed control also. So we can adjust speed also for this motor. Motor 3, control speed, and we can go to see the motors SP-DCL, right? So let's go to open to see the style that we would like to put and then show on the faceplate. Yes, so the class name is MOT SPDCL. So MOT SPDL here. So we can use another style that we want here. SPDCL. Yes. So I will do this style number 6. So I will put number 6 and then compile. Okay, good, no error. And then we can go to insert the motor 4. It is the light motor also, yes. So go to library again, go to block again, library, go to drive, and then go to the motor door speed, right? Okay, I will use this one. So motor 4, motor 4 door speed control. So the class is MOT SPDL, MOT SPDL, MOT SPDL. This one I will use style 5, yes. So I put 5 and then compile the program. Okay, and for the peg 4 we can go to insert the new CFC also, example analog 1. Go to library, go to PC S7 library, go to monitor, yes. Example, the monitor limited monitoring and log value. So example, analog 1, analog 1 monitoring, and the block is AV, right? So let's go to AV. AV. We have analog also, right? So many library that we can use. Okay, we can put one first. And then we can compile. Okay. And we can go to insert one more. CFC analog 2. Go to monitoring again. This one motor analog. Analog 2, analog 2, monitoring. I will put one first. Yes, and then we can compile the program. Okay, no error. And then we can go to C here. Yes. We need to compile the chart. And then we will compile the OS1. Go next again, and compile. So waiting for compile the program that we already created for page 2, page 3, and page 4. So it takes time a little bit because we add many objects. Okay, no error occur, and then we can. Okay, I will close all first for WinCC. After that, we can open again. Yes. Close to refresh the WinCC Explorer. Yes. Okay, and then I will download the program to the PLC. Okay, and then we can run the PLC. And then we can go to open the objects. To open the WinCC Explorer again. And then we can activate again. So wait a moment for activating the project. It takes time a little bit more for activating the project. Yes. Okay, opening the WinCC runtime screen. So wait a moment for opening. Yes. So we will go to page 1. We have 2 motor. Page 2 we have 2 valve. Page 3 we have 2 motor also. And page 4 we have 2 analog. If we would like to modify the screen, we can go here. Example, we would like to modify the screen number 2. the scheme number 2 here. Right now, 2 valve, the small valve, right? So we can go to resize the valve. So open the object. And then we can modify. Okay, I will modify the valve to be bigger than before. Yes, like this. For page 2. And we just save. And then we can go to refresh the WinCC. For page 2, we will got big valve, right? And there are many library or many pages that we can use. Example, we can use the Siemens HMI symbol here. We just double click and we will got many objects that we can use. Yes, example tank we can use here. Mixer for tank, we just click, we can got like this, and we can design the style that we want, and I will show in the next video. Yes, so we just save, we can refresh the screen, so we will got like this. So for page number 3, we can go to open the objects also. And this model, we can resize the screen. Yes. We can design everything that we want, yeah, in this WinCC. Okay, we just save and then go here. Refresh page number 3, we will got here. And for page number 4, we can go to open the object. Okay, to analog, right? We just save. And then we can refresh. Yes, we will got like this. This page, we can start and stop the motor. Slow or fast. Yes, it is slow. And this one we can set the speed for control. Yes, so I will run the CPU back. Okay, so this is just an example about how to create the page or create the objects on the PC S7 version 9.1. Okay, so this is just basic about how to create the project and create the page and also create the basic object that we will got from the library. Yes, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. And I'm also sorry if I have mistake in this video also, and I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use or wiring the PLC Omron CP1E with the power supply and push button, and also connect to the relay control. Yes. And in this section, I will detail about how to create the sample program that we will use the CH Programmer version 9.7 to create the sample project and then control the relay. And I will use the power supply input 220 volt AC and output 20 volt DC connected to the push button start and stop, and I will connect to the digital input side of the PLC Omron. So here is the terminal of PLC Omron. That L1 is 220 volt and natural, and here is the COM that we can connect from the power supply power supply output minus, and for push button I will connect to the digital input number 0 and digital input number 1, and for the output I will connect to relay control. Okay, and I will connect the USB for communication between CH Programmer to the PLC for download the project to the PLC. Okay, so let's go to test with me with the program. Yes, and for wiring there are 8 bits for output and there are 12 bits for input. Okay, so if we would like to use another input, we can connect here, and if we would like to use output, we can connect here. Okay, so this is the input side and this is the output side. So let's go to our program and then create the sample project for test. Okay, so right now I will use CH Programmer to create the new project and then download to the PLC. So let's open. So first we need to create the new project. So file, new, example part 1, PLC 1, yes. And we need to choose the CPU type to match with the hardware, yeah. So right now I will use CP1E, yes, the same as my hardware. And then for CP1E, there are many types of CPU. So in this type, I will use E20 because we use E20, yes, here. It is E20. And then click OK. And for communication, we can use only USB, yes. And this is a driver of USB. So we can command, example, how to wiring and testing PLC Omron model CP1E E20, right? Okay. And then we need to check the communication between PLC and our computer, right? So I will connect the USB from my PLC to my PC. So first we can go to device manager, and then I will connect. Okay, right now I already connected the USB cable from PLC to the PC, and then we can check here universal 3 bus controllers, and here is the driver of Omron. Yes, so the driver is work perfectly, and then we can go to online for check the communication. So work online, and then here is the question that the program asks us to connect with the PLC or not. Yeah, if we try to connect, we can click yes. So right now it can connect. Let's see, the PLC is running and run mode. Yes, and then we can create the sample project. Yes, so before go to create the sample project, let's see the drawing. So I will use I. Yes, I, it will start from, yes, input it will start from 0, and for the output it will start from 100. Yes, so I will put here 100. Yes, so input will start from 0 and output will start from 100. Okay, so 0.0 I will connect with the start button. 0.1 I will start select connected with the stop. Yes, so let's create the push button start. So first I will create button stop. Example, this is a follow our wiring. So it will start from 0.1, right? Example, PB stop. Yes. And for start, I will start from 0.0, right? So PB start. Okay. Actually, we can zoom. I will zoom in. Alt right, yes. We can use the Alt key and right. Yeah. Arrow key right to zoom. And then I will use one output. Yes. So output it will start from 100.0, right? So I will choose coil and start from 100.0, and I can comment. Example, relay 1. Okay, and then we can connect the run. Yes. Okay, good. And if we would like to hold the signal, yes, we can hold the signal here. So this one should be 100.0, right? Relay 1. And we can connect. Yes. And then we can save the project. Example, I will save to desktop and create the new folder. Example part 1, Omron. So this is the part 1, wiring, right? And then we can online and then download to the PLC. So let's go to online. Before online, we can go to compile the program. So there is no error occur. And then we can online. Yes, to online. And then we can, if we online like this, we can test with push button. Yes. And then I will transfer the program to the PLC. So let's go to transfer to PLC. Or we can go here, transfer to PLC. And then I will transfer all. And then stop the PLC and then run the PLC. Okay, and we can go online. Yes. Okay, after that we can test together. So let's go to test with me. Yes, we can online like this, and then we can go to push the button, and then let's see the status of relay. Yes. So here is my PLC Omron that I already wiring the cable from the output to relay, and from the push button to the input of PLC, and then we can test. So this is the start button, so I will push start button. Yeah, let's see the start relay is running, relay is turned on, and then the stator on the program, yes, CA programmer is turned on also. So if we would like to stop, we can stop. Yeah, the condition on the CA programmer is stop also. We can run again. Yeah, so the relay is on, stop again, the relay is off, run again. Yes, the relay is on, so it works perfectly for this wiring. So if we would like to turn on another relay, we can wiring from the another output here. Yes, from another output here, so we can use connect to another relay. Okay, and if we would like to use another address, example the output number 2, output number 3 until output number 7, so we can write like this. Example, I will connect with 100.1. It is output number 2. Example, relay 2. Yes. Connect with another relay, so 100.2. It should be relay 2. Example, I will turn on 5 relay. Yeah. 100.3. So relay 3. Sorry, this one should be relay 3. And this one should be relay 4. And I will turn on one more relay, 100.4, right? Relay 5. Okay. and then we can compile the program, so there is no error, and then we can save. And then we can online and download to the PLC again. So we can click here, transfer to PLC, and then click OK to download and stop the CPU, and then on the CPU back, and then we can test again. Yes, so let's test with me. So let's test again. If I push button start, so let's see output 0, 1, 2, 3 and 4 is turned on, and the relay is turned on also. So this is a child example, so I connect it with only one relay. If we would like to use another relay, we can connect from the terminal number 1, number 2 and number 3, yes, to use. So if I push stop, the condition on the CH programmer is stop also. Start again, it start, yes. So if we have motor or some electrical devices, we can connect from the relay to use, yes. And we can also simulation, yes. So I will stop first and then simulation from the HMI. So I will offline and then close the project first. So I will simulation from the HMI. Example, go to the CH designer. If we install the CH1, yes, Omron CH1, we will got many software that we can use, yes. So right now I will use CH designer. So let's create a new project, and then I will choose the HMI. Okay, this HMI. Example, test with CP1E. Yes. And for communication, we can use this one. Yes. Okay. And I will create the screen one. Yes. And then we can create, yes. Okay, I will open this one first, because when simulation we need to out, right? So to simulation from the HMI, we need to put the another memory, yes. Example for stop button, so I will insert stop button here. I will insert more variable. Example W0.0, it is the stuff from HMI. And for start button, I will parallel with this one. So I will use nominal open, and example W0.1, it is the start HMI. Yes. So I will connect like this. Yes, I will connect like this. Okay. So basically we can start from the HMI and stop from HMI, and we can start from the push button hardware and stop from the push button hardware also, right? So let's save, and then let's design the start stop button from the HMI. So basically we can use the push button or speed here. Example, this one should be stop. Okay, I will use 2. Maybe I will increase a little bit more for font size. Center and center, yes, okay. So this is a stop button, and then yes, we can use this color, and I will copy. This is the start color, sorry, start button. So start button, I will use this color. Yes. And for the stator show here, output, right? I will use bit lamp. Yes. Example, this one I used here. And the color, normal color is out is red, and when on I will show the green. Yes. Okay, like this. Actually this one we can change the color, right? On off also, yes, but no need to change, we just use this step first. And I will copy with the file lamp because the output is file lamp, right? From the address 100 to 100.04. So I will copy. Okay, I will copy file lamp. Okay, like this. And I will put some description. So we can use label. Example, welcome to CX programmer tutorial. Okay, for label I will insert the font size to be like this. It's so big, right? So I will decrease. Okay. Then this one I can change to another color that we want. we can design the style, another style that we want. Yes, from here. And we need to configure the stop, start button and lamp, right? So I will configure the stop button. For stop button from the HMI is W0.0, right? So let's go to momentary and then go to address. Here is the host that we can connect from the serial A to the HMI, sorry, to the PLC. And then I will use the work area and start from 0 and bit 0. And then click OK. And for stop button, sorry, start button, the address is W0.01, right? So I will choose momentary because we need to push, only push. And I will choose the work area also and start from word 0 bit 1, right? Okay. And for the lamp, there are 5 lamps, right? The first one is I will change color to be green color if the stator one, and we will start from the CIO. It means that input and output of Omron, and then the address is 100. Yes, bit 0, and this one we can choose 100 bit 1, right? This one should be 100 bit 2. This one 100 bit 3, and this one 100 bit 4, right? And then we can save the project, and then we can turn off this one first. Save and turn off this one, and we can go to test. Yes, to all, save, and then we can connect from the CH simulator. Yes, and then please start, and we need to browse the project that we would like to simulation with this HMI, right? So I will go to desktop and then go to the folder that we already created. Yes, what is the folder? So part 1 Omron, right? And then part 1 wiring, and then please start to start the simulation. It will download to the simulation automatically, and then we can test from here. Example, I would like to start. Yeah, it will start. Let's see, all lamps is turned on. I stop, it will stop. Start again, it will start again. Okay, so if we have a touch screen, we can connect with the touch screen, but for this CPU it not support with the touch screen. Yes, so we can simulation from this one. Yes, so this is just example, the basic how to wiring the PLC Omron CP1E from the push button and from the power supply to the PLC, and then test with the CX programmer and CX designer for simulation. So thank you very much for watching my video. If everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today we will continue our lesson about how to wiring PLC Omron model CP1E part 2. So in the previous video, we already learned about how to wiring of PLC Omron model CP1E part 1, that we focus only connect from digital output and digital input to the push button, and digital output we already connected to only one relay control. And we also use the CH programmer software to create the project example and then test with the relay control. And we also use the CX designer for simulation from the HMI. Yes, this is a previous lesson. So today we will focus more about connect the relay output from the PLC Omron CP1E to the relays control. So here is the electrical diagram that I already detailed in this drawing. So the first step, we can connect the minus 24 voltage to the coil of relay. Totally I have 5 relays. Then I already connected the cable to the relays. And for the positive, we can connect from the output of PLC to relay, number 1. For output number 2, I connect to relay number 2. Output number 3, I connect to relay number 3. Output number 4, I connect to relay number 4. And output number 5, I connect to relay number 5. But the common, we can jump the cable connect here. Yes, so COM is the same, it is the positive voltage, yes, from the power supply, and then we can connect together with the COM of this terminal. And for the digital input, it will start from I0.0, and digital output, it will start from 100.0 to 100.7. Yeah, totally 8 bits for digital output and 12 bits for digital input. Okay, and in this section I will also use the CA programmer and CA designer to create the new project and then test with this relay. Okay, and we also simulation after we test with the actual real relays and PLC, and then we can create the project for simulation from the HMI. Okay, so let's go with me together step by step about how to create the new project of this PLC. Okay, so let's go. Okay, here is the software CH programmer and CH designer that I already installed in my PC. So first let's go to open the software. Right now I use version 9.7 for CH programmer. Then we can go to create the new project. Yes, example part 2 wiring, and I will choose the CPU to match with my hardware or PLC. So CP1E, and then the CPU type is E20, so we must select to be the same as the hardware, otherwise we cannot connect or we cannot download the project to the PLC. Okay, so right now I choose CP1E and CPU type is E20, and then click OK, and then you can command as part 2 how to wiring PLC Omron CP1E to relay control, and then click OK. We will get the section 1. Yeah, and for section 1 we can also rename as example main logic. Yes, and then we can create the input. So for the input, it will start from 0.0, it is the start, and 0.1, it is stop. So we can type. Okay, I will zoom in a little bit. So press Alt and then a row key right to zoom in. Yes. So we can use the push button. Example stop. So stop, it will start from 0.1, right? Stop button. Yes. And for start button, it will start from I0.0, right? So 0.0 and command as start button. And for the output, it will start from 100, right? It will start from 100. So if we would like to turn on the Q0, it will start from 100.0. Okay. So 100.0, it is the relay 1. Or we can type okay, relay 1. Okay. And then we can hold the signal. Example, I will hold the signal here. So I will hold the signal 100.0. Yes, relay 1. Yes. And if we would like to turn on the relay number 2, we can also turn on. So when Q100.0 turn on, I will let relay number 2 turn on. So 100.1 relay 2, is turned on. Then we can connect the run, yes, and continue. We can use the 100.1 is turned on. Then I will let 100.2 is turned on. This is a relay 3, right? Okay, I will zoom out a little bit. Then we can connect, yes. And then we can continue to create turn on for relay number 4. So if 100.2 is turned on, I will turn on relay number 4. So 100.3 relay 4. Yes. And last one, we can use the contact from 100.3 relay 4 to turn on the relay number 5. So 100.4 relay 5, right? Okay. And then we can earn the program, right? So I will earn the program. And then we can compile, yes. So there is no error. Then we can download to the PLC, yes. So I will save the project first and save keep on desktop. And this one is part 2 wiring. So part 2 wiring Omron. Okay. And then let save again and online. Because right now I already connected my PLC to my laptop via USB cable. So we can transfer from PC to PLC, or we can go here, transfer to PLC. It means that download from our PC to the PLC, and then I will stop the project and then download to the PLC and then turn on, and we can online like this. So when we push the button start, it will turn on together, right? Yes. This one on, this one on, this one on, this one on until relay number 5. Yes. So let's test with me together. Okay, right now I will push button start. Yeah. Let's see the relay number 1, number 2 and number 3. Number 5 is turned on together. And the PLC is shown on also. So if I push stop, the relay is stop all. If I push start again, relay is start again. Yes. So the communication is work perfectly between PLC and relay control. I will stop. Yes. Start again. Yes. So that's good. So if we would like to use the timer for start the relay step by step. We can also use, let me show. So I will use timer. If this one on, I will let this one on, but waiting the timer, right? So let me use timer. To use the timer, we can click here. Yes. And we can write team. Example 0, timer number 0, and sharp 100. Yes. We will got timer like this. And we can use this one instead by timer, right? Example time 0. Sorry. This one should be T0, right? Yes. So if T0 is on, I will let T1 is on. So we can use team. Sorry, here. Example team 1, sharp 100 also. And then I will instead this one with T1. Yes. And when T1 is turned on, I will let T2 is turned on. So team 2 sharp 100. And I will instead this one with T2. Yes. Delete this one. And when T2 is turned on, I will use one more timer for turn on the T3. So TIM 3 sharp 100. We can also use another timer that we want. Yes. Delay time. Okay, I will instead this one with T3. So T3. Yes, it's correct. So I will zoom. Sorry. Okay, we will got like this. So when Q0, 100.0 is turned on, it will wait the timer to turn on relay number 2. When relay number 2 is turned on, wait timer to turn on relay number 3, and then wait to turn on relay number 4, and wait to turn on relay number 5. And if we push button stop, it will reset all. Yes, turn off all timer. So we will compile our program. Yes, so there is no error occur, and then we can save project, and then download online, download to the PLC again. So let me download again. So PLC transfer to PLC. Yes. And click yes again to confirm. Stop the CPU. And then click OK. And run the CPU back. And then we can online. So right now, if I push start, the Q100.0 is turned on. And then the timer will count, and let's start the T 0 and relay number 2 is turned on. So let's test with me together with the real PLC. Okay, so right now I will push button start again. So now relay number 1 is turned on, and wait the timer for turn on relay number 2. Yes. Okay, relay number 2 is turned on, and wait for relay number 3. Yes. For timer we can adjust by the process. Yeah, follow the process. If we would like to fast, we can adjust fast. If we would like to slow, it will we can adjust to slow. Yes. So waiting for timer to start relay number 5. So finish, start, finish, and then we can push the button stop to stop all. Yes. Yes. And we can also start again. Yes. And then the relay will turn on again, and timer is start count again. Okay, relay number 2 is turned on, and then wait for turn on relay number 3, and wait for turn on relay number 4. Yes. So it is just basic. So if we know the basic, we can convert this program to control the process. Follow everyone would like to control. Yes. So right now it's work perfectly, and then I will push stop. Yeah, it will stop all. So it worked perfectly for timer. We start step by step from relay number 1 to relay number 5. So if we would like to simulation from the HMI, yes, we can also simulation. So basically we can start from the HMI, yes. Then example, we use the W 0.0, example start HMI. It means that start from HMI. And for stop from HMI, we can also stop from here. Example W 0.1, stop HMI. Yes, like this. Then we can save, and we can go to CX Designer. Yes. Right now I use version 3.7, and then file, go to new project, and we can choose another HMI that we want. For me, I will use this one. We have many types that we can use. This one example simulation part 2. This one should be sim 2. Yeah, example sim 2. And for system communication, we can go to setting. Yeah, we can change any setting that we want. Example screen 1. We will got like this. And if everyone would like to change the screen, we can go to screen property. Example, change to another color that we want. Example, this color we can use like this. So basically we can use the label for create some text that we want. example PLC Omron tutorial. Part 2. Then we can adjust the frame, we can adjust the label, we can adjust the font size that we want. Example, I will use this size. Yes, so we can apply. It will come like this. And for the text, yes, the text color we can change another color that we want like this. Or we can change the background screen. Yeah. Example, I use the white color. Yes. Or this color. Yes, we can apply like this. So basically we can use the style, we can design another style that we want. Yeah, example, design like this. If we download to the HMI, it will show this slide also. Yes. So right now we would like to start the relay number 1 from the HMI. So I will use the address W0.0. So I will use the bit button. Yes, this one. Example stop. So we can change the size. And for the text color, yes, we can do like this. And for the frame color, we can also use like this. Yes. This is a frame color. Yes. And for the start, we can copy from here and just change the frame to be blue color. Yes, maybe blue color. And this one should be start, right? So I will rename to start. Okay. And we need to show the status of the output, right, to relay. So I will use bit length. So example, this one, relay number 1. Can do this one. Color off is red and color on is blue. Sorry, green. Yes. And then we can copy to file output, right? File lamp or file relay. So this one example relay 1. This one should be relay 2. This one should be relay 3. This one relay 4, this one relay 5, yes. So I will align a little bit to be like this. Okay. And then we need to configure the stop button and start button, right? For stop button, it will start from address W0.01, right? So let's go to config. I will use momentary, yes, and then use the address work area, right? So 0.1, 0.01 here, right? And for the start button, I will use momentary also. And let's go to see the serial A and then choose the work area also. So 0.0, it is correct. And then we can save the project. And for the relay number 1 until relay number 5, we can also configure the address. So I will use command IO area, and then it will start from 100.0, right? This one. So 100.0, this one, 100.1, this one, 100.2, yes, this one, 100.3, and the last one is 100.4. Okay, and then we can save the project, and we can close this one first, and we can simulation by click here, test, yes to all, and then we can choose the connect to CH simulator and browse to find the project that we already saved. Yes, I save to desktop. So part 2 wiring, part 2 wiring, there is empty, right? Oh, this one, let me check. Part 2 wiring, it is desktop, right? On desktop. So I will move to this folder. So this one, yes, part 2 wiring Omron. And then let's start. It will turn on the project automatically, and then simulation, yes. Okay, it will open the screen automatically also, and we can test with simulation, yes. Example, I push start. Let's see, the relay number 1 is turned on, and timer is count also, and wait for turn on relay number 2, yes, and then turn on relay number 3, yes, and turn on relay number 4. The same as we push the button. If we simulation like this, yes, wait for turn on relay number 5. Okay, so right now our relay is turned on, and then we can stop, yes, so it will stop all the relays, and then we can start again. it will work again. Yes. So this is just basic about how to wiring and test with the real PLC, and we also can simulation from the HMI touchscreen. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to upload the program from PLC Omron model CP1E that we can use the software CH programmer, and we can use the USB that connect from the part of PLC to our computer, and then we can upload. There are two options for upload the program from the PLC Omron. The first one is direct online, and the second one we can create the project and then we can online, and we can upload the program from the PLC. Okay, so let's go to our software CX programmer to test and and upload the data or program from the PLC. Okay. In the previous video, we already learned about how to wiring, and we also create the program for control the relay number 1 to number 5. So today we will upload this program to keep our backup on our computer. Yes. So let's go. Okay, so first I will show the first way to back up the program from PLC to save and keep for backup. For this backup is very important, because if the PLC is example the PLC is abnormal or something wrong, example burn or anything accident, so we can use our backup file to download to the new PLC, and then we can use properly without create any program. Okay, so it's very important for backup the file to keep on our computer. Okay, so right now I will connect the USB that connect from the PLC to our computer. So we can go to manage and then go to device manager. Yes, and I will connect the USB, and then I will choose the visual machine. Okay, and let's go to check the device here. Yes, Omron Smart PLC device. Yes, so if we disconnect the cable from here, it will hidden from the universal serial bus controllers. And if I connect again and choose the visual machine, and it will see the Omron driver again. Yes. So be careful if we connect the USB from PLC to our computer. We must check here before we upload. Otherwise, we cannot upload from the PLC. Okay. So let's go to our software. So right now we already opened the CX Programmer software. So the first step, we can go direct online. Yes. And then choose USB. Yes, choose here USB. And then click connect. It will upload the data or program from PLC by search the PLC connection automatically. Okay. So let's click connect to upload the program from the PLC to keep on our computer. So let's click and then choose transfer IO table and special unit setup and click yes, and wait a moment for searching automatic online and search the PLC device that connected with our computer. Okay, so it will detect automatically. Yes, right now it detects one PLC and upload successful. Yes, so we can click OK, and then we can find here our program main logic. We will got the program that we already test in the previous video, right? So in here we can test after we upload the program from our PLC. So example, I will push button stop. Yes, and start again. So the PLC will show the status also. Let's see, the status on PLC is follow our command from the push button. Yes, it will start step by step, the same as the previous lesson. Yes, relay number 3 is turned on. Next step, wait timer for start relay number 4, and next step it will start relay number 5. Yes, okay, and we can save the project to keep. Yeah, I will offline first and then click save. Example, I will create the new folder on desktop. Example CP1E upload. Yes, upload 1. And then if we save, we can go to see here. Here is the upload file. Then we can open. Yes, we will see. And if we online, we can see the status on the PLC. Okay, then we can offline. And we also have the second way. Yes, for upload, we can keep the program also. So first, let's go to open and then choose the new project. Example, upload CP1E upload to, and we must choose the correct device type to match with our hardware or PLC. So right now I will use CP1E, and here is the CPU type, so E20, and then we can command example upload project from PLC Omron CP1E for backup. Okay, and then we can online, yes, go work online, and then we can click yes to online. Okay, so right now the PLC is running status. We can online and run mode. Yes, let's see the status here. And then we can go to PLC and then go to transfer and then go to from PLC, or we can press Control Shift T. Yeah. So let's click here. And then we can choose all. Yes, like this. Command also. Command, run command. Yes. Another from PLC, and then we can click OK. Click yes. OK again. Successfully. And then can go to the main program and then double click here. We will got the program also. So there are two ways for upload the program from PLC Omron. The first, we can use the direct online automatic search and then upload. And the second way, we can create the project and then choose the hardware the same as the real PLC, and then we can online and then transfer from PLC to keep, right? So right now let's go to offline and then save the project. Example, upload to. Yes, upload to. Then we can save and close. And let's check here. We will got two programs the same. The first one is upload 1. The second one is upload 2. Okay. So we can open upload 1 and open upload 2. We will got the same program. Yes. So if any case the PLC is broken or abnormal, so we can use this program to download the project to the PLC, and then we can use properly without write the logic anything. Okay, so it's very important. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. And in the next time I will show and share about PLC Omron also, and we have many functions that we will learn step by step. So please follow me step by step. And for this time, I would like to say goodbye and see you next videos. Bye bye. Hello everyone. Welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to wiring the proximity sensor to PLC Omron model CP1E by using the two types of proximity sensor. The first type is PNP type and the second type is NPN type. And here is the PLC. It is the real PLC, and here is the drawing that I draw for easy to understand for this wiring. So first I have circuit breaker and I have power supply, input 220 and output 24 volt DC, and I connect the power 220 to the PLC for supply, and I will use the program C8 Programmer version 9.7 to create the sample project and then download to the PLC by using the USB cable. Okay, and I will explain to easy for understand about how to wiring the proximity. So for PNP, we already learned in the previous video. So we supply the 24 voltage to brown and blue color of the cable, and then the black cable will generate the plus, yes, generate the voltage positive to relay control. And for NPN, we can connect positive voltage to brown and also connect with the relay, yes, magnetics of relay, and it will generate negative volt to magnetic relay. Okay, so we can follow my drawing to connect this wiring. Actually, if we purchase the proximity sensor, mostly it already draw like this. Yeah, example the NPN, it will connect minus to directly to proximity sensor like this, and plus or positive we also connect to brown, yes, here, and we connect jumping the positive voltage to the coil of relay, yes, so it will work. And I will use nominal open of relay and then connect to the digital input of PLC. For NPN, I connect to input number 0, and PNP I connect to input number 1. Okay, and for the output side, it will start from 100. It means that Q100.0 I connect to one relay, and another output 100.1 I connect to another relays. Okay, so this is a detail about how to wiring the sample wiring of proximity sensor to the Omron CP1E of input and output. Okay, so let's go to our program to create the new project and then test with the real PLC. Yes, and then we will create the sample program for control. Example, control the actuator or control forward and reverse. We can take signal the proximity sensor to cut off the it means that the same as limit switch. Yes, I will detail when we write the program. So first we need to test the input and output from the proximity sensor to the relay, and then check the input on the C8 programmer software. Okay, So let's go. Okay, so first let's open the CH programmer. Yes, I already installed in my PC. Mostly we can use this tool software for create the program on the PLC, and CH designer we can create the project and then download to the HMI. And also we can simulation between CH programmer and CH designer together. Okay, I already show on the previous video. And for this section we can also simulation. Yes. So first let's open CH programmer project, and then we can create a new project. Example proximity sensor, and we need to choose the device type to match with the hardware. It means that to match with the PLC hardware. So our PLC is CP1E and TIA E20. Yes. So we can choose CP1E and go to setting. It has many CPU types that we can use. For me, I will use E20 because we use the hardware E20. And we can communication by using the USB cable. Yes. And this is the driver. Yes. So we can command as connect proximity sensor to PLC Omron CP1E E20. Yes. Okay, we will got the new project, and this one we can rename the program. Example, I rename as proximity sensor. Yes. So it will come to section name is proximity sensor. Okay. So if we have another section, we can also insert the section. Yes. We can insert the section. Yeah. Here, example, I add one more section. Example, forward and reverse. Program reverse logic. Yes. Okay, we will got two sections. One section is proximity sensor signal. I will rename as signal. Yes. And the section 2 is forward reverse logic. Okay. So we can go to test with the proximity sensor signal. Yes. So before go to create the program, we need to check the communication of PLC and PC first. Okay. So right now I will insert the USB cable from my PLC to my PC. Okay, I will use Visual Machine. Yes. And then if the driver is installed properly, we can go to check. Right click on my computer or this PC, go to manage. We can check, yeah. And then go to device manager. And then we can go to universal serial bus controllers. Omron Sigma PLC device. So if I disconnect the USB cable from my PLC, it will hidden, right? I connect again, it will come again, and we can see Omron Sigma PLC device. Okay, so this is how to check the communication between USB cable and computer before we create the program. Okay, so let's go to our program, and then we can go online, work online to check the communication. Yes. Okay, right now we can communication between our PC to the PLC. Let's see, here is the status of PLC is run mode and the program is running. Yes, so we can offline first, and then we test the proximity sensor, right? So the first step, we need to check the input 0.0 and 0.1. For 0.0 I connect from NPN, and 0.1 I connect from PNP. Okay, so first we can go to create the input, example 0.0, right? Example NPN proximity sensor. Yes, NPN proximity. Okay, and I will turn on the output, example W 0.0 output NPN. Yes. Okay, and we can zoom Alt and then arrow key, we can zoom. Yes, and for input of PNP, we can also insert the NO contact, and then I 0.1, right? So this one should be PNP proximity. Yes, and I will insert one more output, internal memory working area W 0.1 output PNP. Yes, PNP, it means that we can get the signal positive to from the proximity sensor and send to the relay control, right? So we can connect. Okay, and then we can test with the real PLC by save the project. Okay, I will save to keep on desktop and then create a new folder. This one should be CP1E proximity sensors. Okay, and then proximity sensors, and then we can go online and then download the project to the PLC, right, for test the signal. So I will transfer, go to PLC and then go to transfer and then to PLC. We transfer all. Yes, so transfer all, and then yes to transfer, and confirm. If we confirm, the PLC will stop, right? So yes to confirm. PLC will stop mode. Let's see here, and then click OK, and then confirm to run. Yes, to run mode. Okay, let's see here, the PLC is run mode and the section of program is running. Okay, so we can test the signal. So let's test with me. Okay, so first we need to test the signal. So NPN time, yeah, I connect to I0.0, yes. If I detect the proximity sensor, let's see I0.0 is turned on, yes. And one more time, PNP, I connect to input 0.1. Let's see 0.1 is turned on, yes. And if I type together, yeah, let's see here, it will turn on together. Okay, so input from proximity sensor is working properly, yes. So we have the signal, right, from the proximity sensor number 1 and number 2, and then we can create the sample program to start and stop for forward and reverse, yes. So I will outline first, and then we can go to section forward and reverse logic. Example, I have start forward, stop forward, and limit switch for cut the signal, right? Because if we have the damper or actuator, we can start forward and reverse, and then cut by limit switch, right? Okay, so first let's go to start, stop. I will stop like this. I will use I 0.2, 0.4 is stop, right? Because right now I connect from push button start and start forward and reverse with I 0.2 and I 0.3. So I will use I 0.4 is stop all, 0.4. Stop all, and we need to start forward, right? Okay, so example, I will use start forward, I 0.2 start forward, start FW, it means that start forward, and then I will use Q 100.0 is command start forward. Example, output forward CMD, because the Omron will start from 100.0 for output for this type CP1E. Yes, so we will start from 100.0. Okay, and then I will connect like this first. Okay, and I will hold the signal when I start forward. So hold by 100.0. Okay, we can write step by step like this, and we need the limit switch for cut, right? So I will use the limit switch. So I will use NC So for NC, we can use from this section. We can use this one or this one. Example, I will use W0.0 is limit switch for cut the signal forward. Yes. Okay, so I can use W0.0. Yes. Okay. And then we need to stop before start reverse, right? So I will insert one more start reverse. Example 0.2, 0.3, right? Start reverse. Okay. And then I will use one more output. So 100.1 output reverse CMD. And then we can connect the wire. Yes. And I will hold the signal by using the 100.1. Yes. And then we can connect the wire. Yes. And then we need to cut the signal when the limit is show the position, reverse position, right? So I will use NC. And then we can use W0.1. It is the output PNP, proximity sensor. Yes. And then we need to put the interlock between 100.0 and 100.01, right? Because we cannot allow the output is working together. So we need to put the interlock. Example 100.1. Yes. And this one should be 100.0. Yes. It is the interlock contact. So here we can push stop from the push button, right? But right now I have only two push button, forward and reverse. So I will put internal memory, yes, for easy to stop. So example, I will use NC and W0.2. Yes, because 0.0 and 0.1 we already used, right? So example, stop reverse, stop forward. And one more example, W0.3, stop reverse. Okay. So when we start forward and then the proximity sensor, yeah, the position is until forward position, the motor will stop by using the proximity sensor for cut, or we can stop from the touch panel or HMI, right? So save the project and then we can download the program to the PLC. And then we can go to PLC and then go to transfer to PLC. Yes. Transfer all. Yes. Yes. Yes again to confirm. Stop the CPU and program is downloading and finish. And we can run the CPU back and the program will online like this. Yes. Okay. So I0.2 is start forward, right? I0.3 is start reverse, and proximity sensor will cut, right? So let's test together. Yes. Let's test together with me. So I will test the button first. It work or not? Okay, it work. So I can stop by push the proximity sensor. Okay, I will put like this. Easy to see. Yes. Okay, so let's test together. So right now I will push start forward. This one example is pull button start forward. Okay, I will push. Let's see, I0.2 is turned on, and then the output is turned on also. Let's see, the signal output is turned on and the relay is turned on also forward. And we need to stop. We can stop from HMI, or we can example it the motor will drive to the position until forward. It will cut by proximity sensor. Yes, so the motor will stop. And if we would like to start reverse, we can push here. Yes, let's see, the output is turned on, and the relay reverse is on. And if we would like to cut the signal, we can cut by tight with the proximity sensor. Yes, so I will tight the proximity sensor. Yeah, so the signal will tight and cut the motor. Okay, and we can start again. Yeah, it will run again. And if we would like to stop, we can stop here. Yeah, stop from the HMI. Example, I write stop. Yes, it will stop the relay. Yeah, I write back to 0. And we can start the by push the button start reverse. Yes, the reverse is start, and then we can also stop from the HMI. Example, I push this one to 1, it will stop. Okay, I back to 0. And if we would like to start the motor forward and reverse from the HMI, we can also add more internal memory. Example, I will insert like this. So we can insert the rung, right? Insert the row. Yes. And then here we can put push button start from the HMI. Example W0.3 start forward from HMI. Yes, and then we can connect, and we can simulation to see the status together. Yes, and I will insert one more for row. Yes, insert row here and use the W0.5, right? So this one should be start, reverse, HMI. Yes, then we can connect here. Yes, and save the project, and then we can go to set up the HMI, right? HMI project, and then we can simulation from the HMI. Yes. So let's go to open CH programmer. Sorry, CH designer for designer the HMI, and then we can simulation together. Okay, let's insert the new project. I will use NS10 V2. Yes, version I will take the last version. So the title program example proximity sensors proximity sensors, and we can browse to find the folder that we already created on desktop and go to communication setting. Okay, and I will use serial A for communication between PLC and HMI, and the type is Sigma PLC. Yes, and the protocol is NT and 1 to N. Yes. Okay, and then I will create the screen one. Okay, we will got screen like this. So we need to create the push button start forward, start revert, and stop forward, right? Stop revert. Yes. Or we can insert one more column for stop all, right? Example, we can stop all from here. Because we need to stop before we run reverse or forward, right? So I can put the stop here. So I will insert the column. Okay, and then I will Control X. Okay, W0.2. I will use the W0.2 is stop all, so no need to have this one, and this one also no need. So I will rename this one as stop all HMI. Yes, stop all from HMI. Okay, so we need to create the button start forward, button start reverse, and stop from HMI, right? So let's go to create here. So I will use bit button right here on our button. So example stop all. So stop all is W0.2, right? So we can go to choose the type. It's so small, right? I will increase the size a little bit. So go to text and then okay, like this, stop all. the label is stop all, and then the color I will change to red. Yes. Okay, stop all like this. And we need to have the button start forward, start forward, yes, start forward and start reverse, right? So we can copy here, start reverse, yes, like this, and we can align. Okay. So this one I will change color to be blue color. Cannot see, right? Maybe I will change to yellow color. And this one should be yellow color also. Okay. So we have start reverse, stop all, and start forward, right? Okay. And then we need to have the signal command forward, command reverse, right? So I will use bit lamp. So example, this one will show the signal cycle like this. Yes. Example, when the output is turned on, it will show as start forward and reverse, right? So I will insert the label. Okay, label here. Go to label, yes. Okay, so we can use the label. Example, this one running forward. Actually, we can design the style that we want. Yes. I will not use the background, but the text I will use green color. Example, this one is run forward. Yes. And I will copy for run backward or run reverse, right? Okay. So we can configure the button. Example for button stop. Button stop is address W0.02, right? So go to momentary and then go to address and working area. Yes, work area W0.02, right? And for the start forward is W0.4, 0.04, right? So working area 0.04, yes. And for reverse start, it will start from W0.05, right? So I will change this one 0.05, yes. And for the forward signal running, right, is 100. So we can use 100, yes. And for backward is 100.01, yes. So 100.01, okay. So we can copy here example start and stop, start forward and reverse from HMI, yes. And then we can increase the size. Oh, so big, right? So we can adjust like this. And for the color, I will change to yellow, okay. And then we can save the project, and then we can close the CH programmer, and then we can test simulation, okay. Connect to CH simulator and browse the file that we would like to simulation. So we can go to CPE proximity sensor and then open the project file and then click start to start the project. It will simulation, yes. Run simulation, okay. So waiting for screen start up, yes. And then we can put like this. Maybe I will zoom out a little bit, Alt and then a row key for easy to see the signal, yes. Okay. And then we can push start forward. Example, I push start forward, yes. The motor will run forward and the output is turned on, yes. And then I will stop all, yeah, stop all. And then I will run reverse. If the motor will run reverse. It's running reverse. We cannot push start forward, right? Because we use the interlocking, yeah, for this one, interlocking between this one and this one, yes. So we need to stop first, and then we can start forward, right? Yes. So that's correct. So thank you very much for watching my video. This is just example sample program about how to use the proximity sensor, how to wiring, and how to create the sample project for test with the forward and reverse, yes, signal. And I hope this video just example. It is just basic for everyone that would like to use the CH programmer and CH designer for simulation. And I'm also sorry if I have mistake in this video, and I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.